when billions of dollars in oil are at stake.
Anytime the pipe's turning to the right, we're making money.
The crew of drill vessel Maersk Viking goes to any length.
It's 7,000 feet deep.
One wrong move equals big consequences.
Set back the whole project by months, maybe years.
Damn, that's it right there.
Coming up!
And mistakes can be fatal.
Don't turn your back on that, it's going out.
Any equipment that is around us can actually kill us.
It's a mission to build one of the deepest oil wells on the planet.
Down, 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 down.
Maersk Viking is top of her class. Just 2 years old, she's a ship that drills for oil in seas up to 3,600 meters deep. That's twice the depth of the Grand Canyon.
150 meters to go.
And her top flight drill equipment allows Maersk Viking to bore an incredible 12 kilometers into the Earth's crust.
Some of the best equipment there is to work with in the drilling industry.
At age 31, Jesse Beck is one of the youngest drilling section leaders in the industry, and he's proud to brag about his ship.
We got the best top drive, do all the drilling, the most powerful, handle the most weight. We've got the biggest and strongest derrick of any rig anywhere in the world.
Jesse and his team are working in the Gulf of Mexico, 320 kilometers south of New Orleans, Louisiana. It's one of nearly 600 American drilling operations in the Gulf, and among the most promising. This oil field alone is expected to yield an estimated 6 billion barrels of oil. Maersk Viking has been working in this oil field for the past 18 months. She's already drilled and built 2 wells that have struck oil.
The Maersk Viking is a very, very good drill ship. But it's not just a good drill ship, it's actually a fantastic ship.
Alan Linder Madsen oversees all operations on Maersk Viking. He's already seen his ship overcome some of the worst weather that the Gulf of Mexico is famous for.
And she's a very seaworthy, she's very strong. Even in bad weather, she behaves fantastic.
Now Maersk Viking is about to get to work on one of the deepest and most advanced oil wells of them all. More than 2,000 meters underwater. But before she can drill, Viking's crew will spend the next couple of weeks building the foundation of the well. That big operation will have 3 main stages. It begins with an 89-meter-long steel conductor pipe that is forced into the seafloor to set a foundation. Then, a second, narrower tube, 975 meters long, called casing, will be stabbed right through that embedded conductor pipe and extend even further into the seabed. Next up, a blowout preventer connected to the ship will be placed on top of the well. It has a set of valves that can be closed in an emergency to stop potential pollution or explosions. Once she's done all this, Maersk Viking will be ready to spend the next few months drilling for that motherlode of oil. It's day 1 of the operation to build the new oil well. First task, joining each one of these pipe segments together to end up with that one enormous 89-meter-long conductor pipe foundation. Each segment, roughly 14 meters long and 91 centimeters in diameter, must be hauled up from the deck by crane, then attached to the next link by a team on the drill floor. This should be completed over the next 14 hours. Meanwhile, a second team of roughnecks gets to work fitting together all the parts of a drilling assembly. It takes 180 crew members to pull off the construction of the new well, from the bridge team
Outside this chart.
to the engine room, to the operators on the 6 powerful cranes. But the roughnecks who thrive on this ship are a special breed. Maersk Viking's drill floor is not a workplace for the faint of heart.
Don't turn your back on that, it's going out.
It is a very dangerous work environment.
So Jesse and his crew watch each other's backs.
At all times, our guys have to pay attention, watch every little detail, watch every piece of equipment.
Once the drill assembly is fully rigged, it's attached to the end of a series of narrow pipes called the drill string. Then it's carefully placed inside the conductor pipe. To prevent it from rattling around and getting damaged, there are knuckles on the drill string that act as stabilizers. Now that the drilling assembly is sitting inside the conductor pipe, a running tool is attached to allow the drill string to lower the whole thing down through this. The moon pool, a gigantic hole in the middle of the ship.
All right, Baba Joe, clear the moon pool.
25 meters long by 12 meters wide, it stretches down through the hull to the water below, providing a sheltered space to lower equipment down to the sea floor. By 10:30 p.m., the first crew of roughnecks has rotated out after a grueling 12-hour shift, and a new team readies for the hard work still ahead.
Once he gives me a thumbs up that it is set, I will verify the slips are set, and then I'll let you pick up on it.
The last big task for today carries the most risk, lowering the conductor into the water.
Just a reminder, we're going to keep safety paramount.
Anybody sees anything, hydraulics leaks, or anything that don't look right, they'll just kill it, press the red button, and shut it all off.
With the drill string suspending the conductor pipe over the moon pool, the team puts a few final touches on the running tool that connects them. Then slowly, the conductor dips into the sea. Tomorrow morning, Maersk Viking will be on the move in preparation for a very delicate operation, more than 2,000 meters down on the ocean floor. Drill vessel Maersk Viking is on day 3 of her mission to build a brand new ultra-deep oil well. She's working an oil field way out in the Gulf of Mexico, 320 kilometers from the city of New Orleans. 2,075 meters down in the ocean, directly below Viking, a huge conductor pipe is dangling from a drill string and hovering 150 meters above the seabed. It's the initial building block for the well. It's time for the ship to reposition above the exact well site and lower the conductor pipe to the sea floor. Next, the pipe will be forced into the seabed until only 4 meters of pipe stick out above Earth.
Yeah, we're gonna be moving 170 to half a knot.
On the bridge, Viking's crew prepares to move the vessel 1 short kilometer to the new drill site.
We're going to be moving, starting off at about 0.2 knots, very slow speed.
Dennis Quapis runs all the marine operations. He says slow and steady counts when the ship is hauling almost 90 meters of conductor pipe below her.
This conductor pipe actually becomes a pendulum below us as it moves around and we move on to location. So the main thing is we want to control that pendulum effect.
Right now the ship is in a safe zone, free of any underwater structures. Between here and the drilling site, though, there's a maze of equipment already set up on the seabed for other oil wells.
Any equipment that goes subsea is extremely expensive, and it's not anything that you want to damage.
Coming off deck.
That's where this underwater robot comes into play. It's a remotely operated vehicle, ROV for short, equipped with 6 onboard cameras.
All right, get ready.
The ROV's high-intensity lights are able to pierce the darkest ocean.
Roger, we're gonna do our arm.
And robotic arms can manipulate tools and do all the hands-on work required to connect or move objects thousands of meters down in the water.
The ROV is very critical to our operation here. Without us, the Maersk Viking wouldn't be able to conduct their operations.
The ROV is launched overboard. It will track the underwater movements of the pipe as Viking moves into position.
Yeah, we're moving now. Half a knot.
Mark Muldoon is Senior Dynamic Positioning Officer on the vessel. It's his job to make certain Viking arrives exactly on target.
You can see the vessel here, and this is our set point here, where we're going to spud in for the well.
As Viking crawls to her new location, the operators in the drill shack observe the underwater progress of the conductor pipe. They're watching a feed from the ROV,
Yeah, Roger, that's where we're going.
which is piloted from a windowless cabin just across the drill floor.
ROV copies.
The key priority is the drill bit, sticking out 30 centimeters below the conductor.
Go ahead, Mark.
Yeah, we've arrived.
We're on location.
Yes, sir.
1 hour after she set out for her very short journey, the ship is in position, poised over the site for the new oil well. Next up, it's time to set the foundation of the new well.
Come down another 2 feet.
All right, coming down 2 feet.
In the drill cabin, drilling section leader Jesse Beck synchronizes the operation.
So right now we're about 4 feet off the ocean floor with the conductor.
His team has to land the conductor pipe on a bullseye, measuring less than 1.5 square meters.
We're getting ready to plant it in the ocean floor as soon as we get between our buoys, our marker buoys.
Those buoys are fixed on the seabed, more than 2,200 meters underwater.
We're going to move the rig in, get us centered as best possible, and we'll stick it in the mud.
That calls for an intense, coordinated effort between the team on the drill floor, the ROV operator in his cabin, and the bridge crew.
How about you on the bridge?
Yeah, this bridge, go ahead.
Let me know when you make that move.
Okay, drill floor, we're gonna be going 5 feet at 170. Starting to move now.
Up on the bridge, there's been a shift change. Now Vince Riley controls the precise moves of Maersk Viking.
Okay, that move's complete. All right, right now we're just doing small increment moves to make sure that we're getting the casing right over the spot.
Because she works in waters that are ultra deep, Maersk Viking can't drop anchor. Instead, she'll use a dynamic positioning system, a computer that analyzes wind and motion sensors to hold the ship in place within 1 meter of her set point. And it means Vince can adjust her location by mere centimeters. Dynamic positioning relies on several thrusters located on the fore and aft sections of the ship. They're synchronized to compensate instantly for changes in wind and waves.
Looks pretty centered to me, Alex. What do you think?
Looks good. All right, coming down.
ROV coming down, bridge coming down.
Roger that, coming down. Everything's looking good.
All right, that's it in the mud.
The drill part has made contact with the ocean floor. It's time to begin what the drillers call spudding in, forcing the conductor pipe down through the seabed to create a backbone for the well. If it doesn't go in perfectly straight, it would be a very expensive error.
don't get it right and we get down so far to where we can't pull this conductor back, then we pretty much have to move over to the side and start over again. Waste $7 or $8 million worth of work.
At this stage, the drill bit inside the conductor pipe doesn't actually cut anything. Instead, high-pressure water is forced out the sides of the jetting device, causing the bit to rotate and force the pipe down into the soft mud.
This is a big milestone for us right now.
After 5 hours of spudding, the conductor pipe is now in position with 4 meters of wellhead sticking out. The rest of the pipe, about 85 meters, is below the sea floor.
We got the conductor pipe jetted in very swiftly and very easy, without any tilt on the pipe.
The crew leaves it to settle overnight to make sure the pressure of the mud locks it in place. A new day dawns with a fresh set of concerns. Remnants of a hurricane are making their way through the Gulf of Mexico.
It's going to cause a drastic wind shift on us.
The drill team is eager to stay on schedule. Next up, they're supposed to release the drill from inside the conductor pipe so it can begin boring down into the Earth's crust.
It's going to affect drilling operations. It'll affect us for being able to do our present operations.
But as much as the crew of Maersk Viking wants to push ahead, the weather may force them to pull operations off the bottom and ride out the storm. On the 4th day of her operation to drill a new deep sea oil well, Maersk Viking is being rocked by the aftermath of a hurricane in the Gulf of Mexico. On the drill floor, the heavy seas and winds clank out a constant barrage of sound through 12 kilometers worth of drill pipes.
All this noise is our drill pipe in the derrick rattling. We call it our wind chimes, and when you hear all these wind chimes going off, that means the seas are very rough.
These rough conditions will make it more of a challenge for the drill team to move ahead with construction of the new oil well. But Maersk Viking has her limits. If things get much worse, they'll have no choice but to shut down, even if that decision costs the client $1 million a day. After waiting out the wind for a couple of hours, the team confirms it's safe to move ahead.
The wind is let down considerably now.
So now the drill team can move on to the next task, which requires them to bore even further into the seabed to make room for the next section of the well. This part of the operation begins inside the conductor pipe, more than 2,300 meters below the surface, when the drill bit is released to tunnel down through the ocean floor. A jetting tool above the bit uses a mixture of water and clay to force cuttings up and out the top of the pipe.
Yeah, go ahead.
Meanwhile, up on the bridge, dynamic positioning operator Wojciech Stelmaszek and Dennis Kwapis react to another shift in the wind and seas.
Rig floor bridge. Okay, we start our heading change.
The bridge needs to adjust Viking's placement over the drill site. Those heavy seas and winds of 30 knots or 56 kilometers per hour are now hitting the vessel broadside. The 6 thrusters are working overtime just to maintain the vessel's position.
If we lost one thruster, the situation could become critical where it may affect our actual positioning over the well as they're drilling.
Yeah, you copy. We start our heading change to starboard 20 degrees first.
The trick is to slightly twist and position the ship so her bow takes the seas head on, minimizing movement on the drill floor. Viking's thrusters allow her to rotate 360 degrees around the drill string. It's as if she were on a giant turntable.
Okay, Cap, we complete our heading change. New heading is 165.
Roger that, 165.
The drill has now reached total depth of 3,185 meters, measured from the onboard rotary table through the water and down into the sea floor. A combination of water and clay is pumped into the hole to displace the seawater and force out the cuttings. This also keeps the borehole open. Once boring is done, the bit is pulled back up out of the drill hole, a process that takes 5 hours.
There's the bit.
At this point, Maersk Viking will creep back and reposition 1 kilometer to the safe zone, carrying that drill string below her. When she's back in the safe zone, the entire jetting assembly and drill are retrieved from the depths, hauled out of the moon pool, hosed down, and pulled up to the drill floor for inspection.
All greased up and ready?
Before the next phase of operations, Offshore Installation Manager Alan Linder Madsen conducts a thorough inspection of all the emergency and backup systems.
The most important part of my job, that is to ensure that the rig is safe, and also that we don't have any kind of spills or negative impact on the environment.
An oil spill would be a catastrophe.
Emergency shutdown panel, all is good.
Something always turns up during an inspection.
We have no idea where they came from.
In this case, it's a seemingly unimportant pin.
But think about it falling down there. What is that? 50 feet, 60 feet? That can actually hurt a person. These are the little things we look for. The little things that actually mean so much in our safety world.
That safety concern extends to the crew. Maersk Viking has gone as long as 5.5 months without anyone on board getting so much as a scratch. Still, no one's getting complacent.
Any equipment that is around us can actually kill us, basically. One of our sister rigs, not a Maersk rig, but another company, same rig, same design, same setup as this, had a guy get killed about 3 weeks ago. So.
It was the first offshore death in the Gulf of Mexico in more than a year, but it's made every crew member that much more vigilant. It's 9:30 at night. Work on the drill floor doesn't stop just because the skies are dark.
Sea state is very rough today. The things are moving. So obviously anytime you pick up something, is a crane or a winch, go to the swing.
But the drill team still has to assemble a new set of piping. 2 days from now, they're scheduled to insert this narrower 22-inch pipe through the conductor pipe foundation. Then embed it almost 1,000 meters into the ocean floor. Just one pipe length weighs in at about 4,540 kilograms.
Everything is heavy here, so that is one of the main challenges.
And there are 77 lengths of pipe in total to be assembled, so the work is repetitive and prolonged. By day 7, only 1/3 of the pipe remains to be assembled. More than 600 meters of it is already hanging in the ocean below Maersk Viking. Drilling section leader Jesse Beck gives the last lengths of pipe a final once-over.
Well, right now I'm just inspecting this part of the 22-inch wellhead. This right here will actually stab into the 36-inch wellhead and essentially lock our new wellhead in. So yeah, just making sure all that's good.
Once all 975 meters of pipe are fully assembled and hanging under the ship, Viking will reposition once again to the well site for installation.
Essentially, this is another building block of the start of this well.
But one member of the crew won't be on board for this part of the mission.
The chopper's 20 minutes out.
It's an isolated life out here on the ship, where crew members work 4 weeks straight, then take a 4-week break.
My relief, he's on his way in. It's always a great thing to see him.
Marine Section Leader Dennis Quapis is happy to be leaving on the hour-and-a-half chopper ride home to his family.
It's been a great hitch. Can't wait to do it again.
Meanwhile, the crew who remain are counting down to a very complex maneuver. Maersk Viking is on day 8 of construction for an ultra-deep-sea oil well in the Gulf of Mexico. She's creeping at 0.1 knot into position over the wellhead. A casing pipe almost 1,000 meters long is dangling below her.
Tell Devin and them I'll be making up on this one, please.
That adds another level of caution to the next step in the operation. It's time to stab the 22-inch diameter casing pipe through the wider 36-inch conductor pipe, then embed it almost 1,000 meters into the ocean floor. It's like threading a needle more than 2,000 meters below the ship.
We definitely don't want to hit the 36-inch wellhead and damage anything before we even get the 22 in it.
This is when the 6 cameras aboard Viking's ROV will really prove their value to the mission.
7,000 feet above the wellhead is kind of difficult. So, yeah, we'll get ROV to guide us. They'll be our eyes down there.
At this point, the bridge has maneuvered Viking into position above the wellhead. The 22-inch pipe hanging below her is just 52 meters above the sea floor.
Hey, ROV.
Bridge, ROV.
Follow us down. I want to get about 5 feet above the wellhead, and then you can discuss with the bridge to get us exactly lined up.
Yeah, roger that.
From his perch in the drill shack, Jesse coordinates between pilot Randall Roy, who is working inside the ROV cabin on the main deck.
Yeah, that's where we're going. 60 feet.
The drill team that is moving the last few pipe lengths below the ship. And Bobby Joe Green, the operator who finesses the pipe movements underwater.
Let me get y'all to come to a stop. We're gonna back off and try to get the top of the well in view.
All right, we're all stopped, Randall.
Now the pipe is within striking distance of the wellhead.
What are we, about 2 feet up, 1.5 feet, something like that?
Off the well?
Yeah.
I'd say about a foot, maybe.
Okay, cool. Yeah, come up and look in the hole and we'll stab it this time, I think.
Half a meter, 195. Starting the move.
As the drill team moves in for the stab,
ROV bridge, 1 meter, 325.
dynamic positioning operator Vince Riley shifts the massive 228-meter-long drill ship ever so slightly.
We're making very small, precise movements, making moves 4 meters, 1 meter, at speeds of anywhere from half a knot to even 0.1 knot.
Look pretty good to you, Randall?
Yeah, it's just swinging back and forth.
Yeah, it looks like we'll have to get it on that swing.
Yeah.
The underwater dance continues for 8 agonizing minutes as the 975-meter-long casing pipe sways tantalizingly close to its target.
That ain't it. That still ain't it.
Just when it appears the pipe will slide right in, the casing gets caught up on the lip of the wellhead.
This thing is riding the rim.
Yeah, it's rubbing on the backside. Hey, Randall.
Yes, sir.
Could y'all give it a little nudge?
Jesse gives the go-ahead to prod the pipe gently with one of the ROV's robotic arms.
All right, Bob Joe, make come in this time. Stop. There it is, down. Down.
There you go.
All right, we're in. Good job, Bobby Joe.
Now that they've pulled off the stabbing, the next step is to bond the two pipes together. 400 tons of cement are pumped down the interior pipe, first filling the bottom, then shooting up the sides to fill the gap between the interior pipe and the conductor. Once set, this glues the two pipes together. There is no such thing as quiet time on Maersk Viking. Something's always cooking. The 180 men and women on this ship work hard, and they expect to eat hearty. In a typical month, the galley serves up 250 kilograms of French fries, 900 kilograms of chicken, and 380 liters of ice cream. As if their work wasn't tough enough, some of the roughnecks, like Jonathan Melson, choose to burn off the calories from those generous meals with a round of weights in the gym.
If it's the line of work that we do, we gotta have, be in shape to keep working.
That strength training is about to prove its worth as the drill team readies to install the blowout preventer. Weighing in at nearly 450 tons, it's designed to prevent the uncontrolled eruption of flammable oil and gas. In the event of a blowout, the valves on the BOP kick in and seal off the well before the oil and gas can reach the ship.
Sheldon, are we good?
Once Maersk Viking starts drilling for oil, the BOP is the last barrier that stands between the ship and a fatal explosion.
Start the blue pod function test from the rig floor, please.
Subsea supervisor Mick Hall and his crew are testing the blowout preventer systems using an environmentally safe fluid.
Upper pipe runs. Closing.
All valves pressure tested to full pressure, and the function test is going well as well.
Within the next 2 days, the blowout preventer will be lowered through Viking's moon pool and locked onto the wellhead on the ocean floor. It will be connected to the sea surface and the ship by steel tubes known as risers. As the sun rises on day 9 of their mission, Maersk Viking is back in the safe zone.
Where's the roughneck?
The drill team prepares to move the blowout preventer over to the moon pool. Everything has been leading up to this, the mother of all moves.
Now, we don't want everybody shouting directions and things like that. The only time is everybody and anybody can shout stop.
Mick Hall gives a last-minute safety briefing to his crew.
And if you feel you need to stop the job, we stop the job, right? And we'll come and we'll look at what the issue is and we'll fix it. Okay, right, guys, everybody knows what they're doing. Let's get on with it.
The first step is for the crane to lift the huge blowout preventer so it can be loaded on a transporter, which in turn will move the BOP into position above the moon pool.
Ready?
When y'all ready.
Roger that.
We're coming up! You good level-wise? Keep it going. Good job. It's going good. Nice and slow, nice and steady. That's what I like.
But Jesse is still holding his breath.
Everybody's kind of tense right now because it is a heavy lift, and any slight movement at all will make that 983,000 pound shift, which will do a lot of damage.
If the wellhead or BOP is damaged at any point during the maneuver, the crew could be forced to start over, building the entire well from scratch. Millions of dollars of time and equipment are at stake. It's day 9. Stage 1 of the most critical move of Maersk Viking's mission has just begun.
Hit your point for your level. Until it gets lower, then I can help you.
Mick Hall is directing the blowout preventer to a transporter cradle. It's en route to the moon pool. And then a voyage to the bottom of the sea, where it will be installed on the wellhead.
Okay, ease her down. Down.
Shifting the nearly 450-ton BOP is painstaking.
All stop. What's that?
Employee cap on this side. And you're rubbing over there.
The fit isn't quite right, so it has to be repositioned to make the 25 millimeters of clearance.
Yeah. Looking good, Matt. Keep it up. Looking good. All stop. All stop.
Now that it's firmly in place in the transporter, the next challenge is to skid the BOP over on rails to the moon pool. Every loose cable must be accounted for and fastened.
These three black cables right here is what essentially runs that BOP. So we got to make sure we don't nick them at all.
This blowout preventer is the last fail-safe that can protect the ship and her crew from a catastrophic blowout when they start drilling for oil.
Hi, buddy.
What's up?
Oh, how's it going?
Good. Let's slide it up under the riser.
Right.
Tell Wilson to pull back on the tugger.
The BOP is now poised over the moon pool. Meanwhile, the drill team has begun assembling a structure called the riser pipe. When the well is completed, the riser will connect Maersk Viking to the blowout preventer sitting on the wellhead. Each of the riser sections is 27 meters long and weighs about 34,000 kilograms.
Okay, you can spin back now. We're stabbed. Whoa.
The last sensitive move is to attach the riser to the blowout preventer.
Okay, ease it down. Ease it down.
The combined worth of the BOP and riser is a whopping $80 million. That's the cost of a brand new freighter, so an incremental move like this can't be rushed.
It's a very delicate operation to get the pins stabbed so we don't damage seals, we don't damage pins.
It's not just the value of the BOP. Mick wants to make sure his crew gets through this crucial step with all their limbs intact.
Guys can get hands trapped. That's why communications is imperative at this point. Nothing happens without my say-so. All stop, all stop.
Finally, the BOP and riser are splashed through the moon pool. It will take 48 hours for the remaining riser to be added and lowered. When it's completed, the combined riser and BOP will measure in at more than 2,200 meters and hang directly below the ship. Day 11 of Maersk Viking's mission dawns under gray skies. It's been 3 days since the operation to install the blowout preventer began. Now, a fast-moving cold front is blowing through the Gulf of Mexico. Although the ship has moved to within 150 meters of the wellhead position, the BOP installation is on hold. Viking is built to handle the predicted 45 knots of wind, but a cautious Alan Linder Madsen sees no reason to push her limits.
We'd rather wait these 2-3 hours and then do it right from the start.
Finally, by the evening, the worst of the storm front has passed through.
Here we go.
The ship's ROV is launched in anticipation of the high-stakes move to land the BOP on the wellhead. Because the move is so complicated, a second ROV launched from the nearby supply ship will also monitor the installation.
So 130, 104.
On Viking's bridge, dynamic positioning officers Jessica Chernik and Wojciech Stelmaszek work in sync to precisely maneuver the ship.
Yeah, they said they wanted to start making the move to 20 meters off the wellhead, right? Okay. Sea installer, Maersk Viking bridge. We're going to be working in conjunction with the drill floor and also with the ROV to be moving the vessel towards the wellhead, making sure that we, don't hit anything on the way there. ROV drill floor, this is the bridge.
It's not only the BOP and riser at risk. The crew has to keep a sharp lookout for the web of infrastructure already laid out on the ocean floor. The stakes are enormous.
It's not just our own equipment that we risk to damage. This could also be these multi-million-dollar installations down here, and that will set back the whole project by months, maybe years.
Because this is the final critical step, Mick Hall and Jesse Beck rally their team again for a breakdown of the move.
I'll be at the ROV. I'll be telling the bridge whatever moves to make. Jinx, unless you hear my voice, don't.
Jesse is the eyes for Graham Jenkins, known as Jinx, who controls the BOP via instruments only.
Landing mode stuff set up, Jinx.
But right now, video from the ROV shows that a strong current is causing the BOP to sway slightly. That creates more of a challenge to land it on the wellhead.
It may take a little time to get it to settle down, to get it latched up. I don't know, but we don't want to make any mistakes, so everybody just be quiet. Jinx, don't move until I tell you to, and we'll get it latched up.
As the blowout preventer begins its final descent toward the wellhead, Jesse heads to the ROV cabin.
All right, let's come down about 10 feet.
This is serious business.
Okay, coming down.
If Jesse's team is even slightly off the mark, that one wrong move could smash the BOP right into the wellhead.
So close. Taking a chance of running that wellhead is it makes it a very tense moment. So you just have to let these guys do their job and make the right call at the right moment.
Roger that.
All the pressure of this pivotal move rests on Jesse's shoulders now.
Yeah, go ahead. Okay, coming down.
I'll stop, Jinx.
I'll stop.
Jesse Beck and his team are in the last grueling stage of lowering the blowout preventer onto the wellhead.
Going as slow as I can. Roger.
With less than a meter to go, the two ROVs maneuver in for a closer look with their cameras.
Yeah, it looks like it's getting close. Very close. Yeah. Jinx.
Yeah, go ahead.
All right, coming down, I'll tell you when to stop.
Just then, the BOP starts to swing away in the current.
I'll stop.
Jesse needs to time the next move, so the swing back happens at the very moment when the wellhead is directly aligned.
Jinx, get ready.
With the BOP so close, Jesse calls for a tiny shift in the ship's position.
Yeah, go ahead, ship.
All right, I need to go a foot at 37 degrees.
No, 1 foot 037.
Copy.
037?
Yeah.
037.
Damn, that's it right there.
On the move.
Roger that. It's lined up on the other. Jinx, come down. Damn, come down. That's it.
Yeah. She's down.
All right, Jinx, go to your 100K down and we'll latch it.
Copy.
Good job, everybody.
Everyone, from the ROV shack to the bridge to the drill floor cabin, can now exhale. The BOP has finally been landed.
Relieved. We didn't destroy anything or tear anything up. It was good landing. Everything went well.
Now it's time to look ahead to the ultimate goal, tapping into that giant reservoir deep down in the oil field. This new drill bit, made with synthetic diamond cutters, will start boring through the Earth's crust in search of that liquid gold. Jesse expects to hit the oil reservoir in 10 to 12 weeks.
Anytime the pipe's turning to the right, we're making money, so of course I'm always happy.
And Alan Linder Madsen can be confident of a job well begun.
absolutely perfect and very good performance of the crew. No damages, no nothing, efficiently, safe and good. And the guys around the ship are happy. Now we are doing what we like to do, drill holes in the soil, and it goes very good indeed.
For the crew of Maersk Viking, this has truly been a voyage to the bottom of the sea. She's called Solitaire, one of the biggest, hardest working ships afloat.
There's nothing better than this. This is the best.
Her job is to lay pipeline on the ocean floor in some of the world's deadliest waters.
The waves out here can get pretty treacherous.
She's ready to set sail on her toughest mission yet.
This is always a very exciting part.
In the cold, cruel Norwegian Sea.
That's where the rubber hits the road right here.
The pressure is on. Can Solitaire deliver? MV Solitaire is one of the toughest, busiest ships in the world. Every year, she lays over 3,000 kilometers of oil and gas pipeline. Solitaire is one of 50 pipe layers working today. But at over 400 meters, that's the size of an aircraft carrier. She's the biggest of them all. Captain Fred Regtop is proud of his mighty ship.
We're very strong. We've got a lot of power. We're not only the biggest pipe laying, but we're all one of the longest ships in the world, but also the strongest ship in the world.
And when it comes to the business of pipe laying, Solitaire is the heavyweight champion. The ship is a floating 3-story factory, the size of 4 city blocks. Below deck, hundreds of workers build kilometer after kilometer of pipeline on a constantly moving assembly line. The pipeline is fed out the stern of the ship like a giant spaghetti noodle and directed down to the seabed along a 140-meter ramp called a stinger.
Yeah, it's where the rubber hits the road right here. This is where the pipe meets the water and it goes to the bottom.
It takes several special teams to choreograph the ship's operations. Down in the factory, the pipe is welded together and fed onto the assembly line, while engineers keep a close watch on where the pipeline is laid. Up on the bridge, the ship needs to be held rock steady as the pipeline is fed off the stern. From the factory floor to the ocean floor, Solitaire can lay up to 9 kilometers of pipeline a day. No other pipe layer can do it any faster, and that makes her the #1 choice of oil and gas companies around the world. Statoil, the world's largest developer of deep-sea gas projects, has just hired Solitaire for a job in the notoriously rough Norwegian Sea. Ole Magnus Holden is a Statoil engineer, and he's counting on Solitaire to solve a problem only she can handle.
Quite depending on the effectiveness of this vessel. So that's very, very important.
120 kilometers off the west coast of Norway, the Ormen Lange gas field development is one of the largest in the world. When it's completed, it will supply the United Kingdom with 20% of all its natural gas. Solitaire is here to help finish the project. Her job is to lay a pipeline connecting a new gas well to the main line. It's just 12.5 kilometers long, but the seafloor is rough, rocky, and dangerous.
It's not a simple job. It's definitely not simple. The pipe laying process altogether, how the pipe is arriving onto the seafloor, is really difficult.
She's also on a very tight deadline. Solitaire may be the fastest pipe layer in the world, but this job needs to be finished in just 2 weeks. The stakes are high, and Solitaire's world-class reputation is on the line. She'll need a world-class crew to help her deliver. Stavanger, Norway is the gateway to the Ormen Lange gas field. Pipeline workers from 21 different countries around the world have come here to work on Solitaire.
Senior barge foreman, and I'm a spacer on board the Solitaire.
I'm a coating operator.
Gran operator.
TJ Clint's pipeline welder. LaRue Lambert, the pipeline welder.
TJ and LaRue hail from Texas. They're used to big spaces, and that's a good thing, because Solitaire is 8 stories tall and has 10 kilometers of corridors.
This is home sweet home. See it.
The accommodations aren't luxurious, but for a big working ship, they don't get any better.
Believe me, where I've been before, it's paradise.
But right now, it's more like hell for the ship's head of administration, Hans Vierdege.
On mobilization day, I'm hectic. Yeah, it's crazy.
He has to process over 400 people and get them settled on board Solitaire fast.
You know, every time you're laying somewhere, you're sitting still, you're not making any money at the end of the day. So it is this case to get people on board as quickly as possible, get going as quickly as possible, get to the job as quickly as possible, and start as quickly as possible.
Hans doesn't mess around. By the end of the day, Solitaire is ready for sea.
Everybody's on board so we can go.
It's 200 kilometers from Stavanger to the Ormen Lange gas field. But Solitaire is a fast ship, and she'll reach it in less than a day. Her massive 96,000-ton bulk makes for a smooth ride.
You don't hardly feel it go, and you don't hear any noise, you don't feel nothing.
Working in the Norwegian Sea, where waves can reach 20 meters, she'll need that stability. Statoil is betting their mission on it.
Solitaire is a very, very stable vessel, which is quite suitable in these conditions. We are totally depending on the stability of this vessel.
Down in the factory, it's rock solid. 200 men are moving pipe around, preparing for the Ormen Lange job.
Going into that down the back and back.
Construction boss Keith Hassage is another Texan, and he's worked on pipe layers for 35 years. It's his job to keep the factory running smoothly.
That's fine there, okay. So we try to move out as much pipe in 24 hours a day that we possibly can.
While the factory crew gets ready below deck,
Hi, good morning.
Keith meets with the project engineers. A working day on Solitaire costs hundreds of thousands of dollars, and they're nervous.
Look into the detail. That won't hold us up. Right. Pipeline operation. That's the most important thing. Right. On our response.
Statoil is worried that the job won't be completed on schedule. Extra days could bust the budget in a hurry.
That won't hold us up. It's just what I'm worried about is it will take a very long time. Possibly need to concentrate on overwork.
Oh, we are. I mean, we're continuing with our PTTs.
They're nervous for good reasons. It's springtime, and the weather is holding for now, but it can turn ugly without warning in the cold Norwegian Sea.
We've got all the natural wind, current, waves, swell, thunderstorms.
So it's very important that we get this installed and connected to the main line during this season. We really have to get this done.
Unpredictable weather and an uncomfortable client. Forget her world-class reputation. Solitaire is going to have to prove herself all over again. MV Solitaire, the biggest pipe layer in the world, is on her way to a tough assignment at the Ormen Lange gas field in the Norwegian Sea. So far, she's made good time.
the moment we're doing 12 knots, almost at the location. So we're 6.5 miles away from the location.
On the horizon, there is absolutely nothing to indicate that this is one of the largest gas fields in the world. No drilling rigs, no ships, nothing. But 850 meters below, it's another story. 2 subsea gas wells are busy pumping natural gas up from beneath the seabed. The entire gas field is a virtual spider's web of pipe. More than a dozen feeder lines connect to a main line that runs 120 kilometers to a refinery on the coast of Norway.
And that is where the pipelines come into play. We are totally depending on the pipelines in order to transport the gas from the reservoir and to the market.
It's almost midnight by the time Solitaire reaches Ormenlange. The crew get right to work and prepare to lower a guide anchor, the first stage of laying the pipeline. The guide anchor will direct the pipeline down to the exact spot on the sea floor where it will connect to the new gas well. That spot is called the target box. It's just 3 meters by 3 meters in size and 850 meters underwater.
In this water depth, it's the smallest box we ever had to lay that pipe in that the box is so small, it's very hard to hit it.
If they miss, the pipeline won't connect to the gas well, and they'll have to haul it up and try again. All eyes are on the anchor as it takes the plunge. The guide anchor drops towards a locator beacon on the bottom. When it's in position, a fixed length of cable from the anchor to the ship will guide the pipeline down toward another target beacon. When it's right over the target, the cable will lower the pipeline right into the box. Up on the bridge, construction boss Keith Hassage and machine operator Jorge Hermo watch closely as a winch pays out the cable.
With the winch drive, it could fail, then you'd have a big tangled mess.
To prevent that mess, first mate Ilya Volthaus adjusts Solitaire's state-of-the-art dynamic positioning system that keeps her rock solid over the target area. Wind sensors, motion sensors, gyro compasses, any data affecting the ship's position is fed into a computer that controls 8 thrusters. They're the biggest in the world. And because of Solitaire's massive size and her need to maneuver accurately, they all have to work perfectly. The thrusters' engines produce enough horsepower to drive 20 tugboats, but with slight adjustments, Ilya can maintain a position measured in just centimeters.
So what we are doing now is just keeping the boat on the same location till the tail anchor is on the spot on the bottom.
An hour ticks by as the anchor descends. They cannot make a mistake. The anchor has to land in the right location. If it doesn't, the anchor cable won't lower the pipeline onto the target. Keith watches and waits for the anchor's depth gauge to hit 850 meters, the bottom.
And we still have approximately 500 meters to go, put it on bottom, and that'll take about another, 50 minutes or so.
But just minutes later, suddenly the anchor touches down. That wasn't supposed to happen.
92 meters off, I think.
It could be a faulty depth gauge, or the seabed survey is wrong. But either way, it's a problem.
Yeah, about 90 meters. It's not real good, is it? It surprised us. We weren't really ready for that.
Technicians arrive to fix the problem, while Keith looks on with the patience of a 35-year veteran.
It won't be the first, it won't be the last.
It's been a long day and night, and Keith is running on fumes, but he won't leave the bridge until this mystery is solved.
It's almost breaking daylight, boys. Almost breaking daylight.
He's lucky. It doesn't take long to find the glitch.
Yeah. See you in a bit. See y'all later.
The depth gauge did malfunction, but somehow the anchor has ended up exactly where it should be. Finally, Keith can get some sleep. Down in the factory, everyone's up and working. With the anchor secure on the sea floor, it's time to start laying pipeline. But it's a false start. Back up on the bridge, surveyor Arjen Porcius and engineer Wouter van Wagtendonk have spied another problem. The beacon on the anchor cable has slipped in the mud.
Oh, this is strange. Yeah, well, yes. Because there's really a difference between those readings. Yeah, indeed.
If it has moved out of position, they can't drop the starter pipe. Keith is hauled out of bed. Captain Regtop has to figure out what to do fast. The Ormen Lange job has just started, and already the fastest pipe layer in the world is behind schedule. MV Solitaire is in the Norwegian Sea and ready to lay down a pipeline at the Ormen Lange gas field. But work on board has come to a grinding halt. An anchor to help guide the pipeline to the bottom has slid out of position. Captain Regtop isn't even sure where it is. The anchor's locator beacon has gone silent.
We don't know exactly how much it slipped because it's disappeared in the mud.
There's only one solution: haul the cable out of the mud and start over. It's a costly delay for Statoil, Solitaire's client. The anchor cable is winched up and then lowered back down. Cameras on an ROV keep an eye on the cable as it heads back to the bottom. Exhausted and impatient, construction boss Keith Hassage wants an update.
Okay, just keep us updated from time to time, if you would, please. Just so we aren't sitting over here with a thumb up our ass or whatever.
30 minutes later, it's confirmed. The guide anchor is in the right spot, and this time, it's holding.
Success, yeah. It's nice to know. Yeah.
It's a crucial success. With the guide anchor in position, the crew can now start phase 2 of the job. Lowering Solitaire's massive 1,250-ton Stinger into the sea. Hanging off the stern of the ship, the Stinger helps guide the pipeline down to the sea floor. It goes in without a hitch.
It takes everyone on this vessel to make this vessel work.
Down on the factory floor, a rigging crew muscles the starter pipe onto a tensioner. By the time it reaches the sea floor, the pipeline will be 1.5 kilometers long and weigh over 200 tons. The tensioners will stop it from crashing to the bottom.
We must be able to hold on to it. That's the whole challenge. That's how our system is built also. That's why we have those tensioners.
A slip-up would be a disaster, so the crew always tests the tensioners first. They feed in a length of pipe attached to a thick cable, and the tensioners clamp down onto it. Then, over 200 tons of pressure are placed on the cable, simulating the weight of the pipeline. Everything looks good.
This test is okay. It's approved.
Now that the tensioners have checked out, the factory crew can load the critical first length of pipe onto the assembly line. The starter pipe has a nozzle on one end that will connect the entire pipeline to the subsea gas well. If it gets damaged, it's an expensive fix. Once the starter is loaded, the next pipe is welded in place. Now the assembly line really starts to move. Each length of pipe is 12 meters long and weighs over 2.5 tons. One by one, they head down the line. The tensioners gently feed the line out onto Solitaire's stinger, and the starter pipe disappears into the sea.
It's a landmark any time that we get one of these things initiated without too much trouble.
Finally, they're ready to lower the starter pipe 850 meters down to hit the 3x3 meter target, something no pipe layer has ever tried to do.
You know, you're trying to do it, drop it on there and see if you can hit it or not. That's about what you're trying to do.
To make matters worse, the sea floor at Ormenlange is riddled with peaks and valleys, dangerous terrain for laying a pipeline.
The seabed is not a nice, smooth surface, but it has a lot of mountains here, sub-mountains. That's one of the challenges here.
Everything is a challenge on this job. Slowly, the anchor cable lowers the pipeline, heading, they hope, right for the target box. The pressure is on. If they miss the 3x3 meter target, they'll have to do it all over again. A huge cost in time and money.
Okay, can we just get on with it, or would you like us to get instructions from you pretty soon?
The ROV tracks the starter pipe's descent. 300 meters to go. $100 meters to the target.
This is always a very exciting part of it.
$5 meters. The starter pipe touches down and misses the target.
And we're now about 50 centimeters out of the small box.
They didn't miss by much. The 50 centimeters is still a failure. The crew, however, are not giving up.
We do everything in our power to get it working and to get it in that box. Only we cannot swim underwater and push it to the right area. So.
Keith and Captain Regtop have a radical idea.
So we're trying to get it down, the tension down, and slide it back a little bit, but we're not sure if it'll move.
They want to back their giant ship up just a few centimeters and try to slide the pipe into the box.
A little bit, we feel like we maybe have possibility of just adjusting it by about 30 centimeters.
It's a huge gamble. Sliding the starter pipe could send a shock wave up the 1.5 kilometers of pipeline, cracking the welds. Solitaire starts to back up very carefully.
Still creeping. Just moved a little bit, but not much. Slowly.
The ROV reports the starter pipe's new position.
7030900.42.
It looks like sliding the pipe might have worked.
Damn, that's close. You can't even count that.
But then again, maybe not. The starter pipe is right on the line. In a tennis match, that counts as in. But in this game, it's a judgment call.
On the line, that is still a doubtful situation because we are still discussing the latest fix.
It's now up to Statoil, Solitaire's client, to make the call. Is the starter pipe in or out? Hundreds of thousands of dollars are riding on the answer. MV Solitaire, the world's largest pipe layer, is 120 kilometers off the west coast of Norway. She's just laid down the first pipe on a job in the Ormenlange gas field, but there's a problem. The starter pipe has to land in a target box just 3 meters by 3 meters, and it's right on the line. It's now up to Statoil engineer Ole Magnus Holten to make the call. Is the pipe in or out? If Solitaire missed, her crew will have to start over, and no one wants that. Ole makes his decision. It's in.
They made it, yep. It's very good.
The gamble to slide the pipe into the target box has paid off. For the crew, it's a triumph. And for Solitaire, it's another first.
Solitaire now has the record of the smallest box in the deepest water here.
Oh, it's very happy. Yeah, it takes a lot of pressure off, I can tell you that, you know.
The bridge crew and engineers have done their job. Now it's up to the factory to get to work and lay down the rest of the pipeline as fast as possible. The operation starts in the holding area, where a crane lifts sections of pipe onto rollers. From there, the pipe moves down the assembly line to the beveling station. Here, both ends of the pipe are ground smooth to make the joint snug. Then, the spacers fit the pipes together.
We just put the pipe together and line it up correctly in the inside before the guys start welding it. If it's not lined up properly, it'll make a bad weld.
And one bad weld could destroy the entire pipeline, making the welding station the most important stop on the entire line.
You just gotta pay attention to what you're doing.
The pipeline has to last for the 30-year lifespan of the gas field. But if any of these joints springs a leak, it's finished. Seawater corrodes exposed steel pipe fast and could cause both an environmental and financial disaster. The fate of the pipeline is literally in the hands of Solitaire's 30 master welders. Kevin DeJean is their foreman.
Welders are always good. They, a lot of them experienced from prior vessels. Been welding all their lives, so we have good welders on board.
TJ Klitz has been a welder for 15 years. He makes it look easy.
Yeah, everybody works pretty fast. It ain't tough. I guess your eyes, it takes wear on your eyes after a while.
Solitaire is so big, she has room for 2 welding factories. That's double the production of any other pipe layer and gives this mighty ship a big jump on the competition. It means that welders can work on 2 sections of pipe at the same time, making Solitaire twice as fast as almost any other ship in the business. After the welders have done their job, the tensioners clamp down on the pipe and feed it slowly toward the stern, 24 meters at a time. The last stop on the way out the door to the stinger is the coating station. This process helps bond the joints and prevents the pipeline from rusting. When the assembly line is up and running at full speed, everyone in the factory has to stay heads up. This is a dangerous workplace.
We always watch each other's backs, working as a team.
The biggest danger is the pipe itself. If someone is standing in the wrong spot or a pipe moves unexpectedly, an injury could happen in a split second. Solitaire's full-time safety officer, Milan Milolaza, patrols the ship constantly from the factory floor to the main deck, looking for potential hazards.
The danger here would be that if people caught in between these 2 rollers with a pipe coming his way, the pipe will not stop. This equipment is all hydraulically powered equipment that will not stop in case somebody stands in front of it. And my job is to prevent people from trying to take a shortcut. If the cable comes up, the sudden movement, it could hurt somebody seriously. Just imagine 100 tons or 200 tons tension on the cable, with the cable breaking or coming up or down on your leg.
With the factory humming safely, up on the bridge, Captain Regtop maneuvers Solitaire to make sure that his ship and the pipeline stay on course. Using data from locator beacons on the sea floor, he follows a corridor that was excavated 1 year ago. The corridor is just 2.5 meters wide. If Solitaire strays off the line, it could wreck the pipeline.
And we need to avoid laying the pipe over these peaks. And you can imagine in a water depth of 850, it's quite challenging to hit such a narrow corridor.
When a 24-meter section of pipe is ready to be laid down, Captain Regtop uses Solitaire's 8 thrusters to nudge the ship forward by exactly the same distance, paying out the line and then stopping and holding position.
All the stations are ready to make another 24-meter pull. So I accepted here the reset all the alarms, and just with one pull, we moved 24 meters ahead. And now the vessel is moving ahead to the next set point, and will stop exactly where the pipe needs to stop.
If he moves his ship too far forward, the pipeline could snap in half. But Solitaire's thrusters allow Captain Regtop to maneuver her 496 meters as easily as driving a compact car. Back down on the factory floor, construction boss Keith Hassage seems to be everywhere. Right now, he's looking for bottlenecks on the assembly line.
Anything like that, let me know. You have a shortcut like that, okay?
Are we going to use that pipe out of the hole, that 16-inch head?
We use that Gulfco pipe, whatever that is. Did that work all right? Things working all right here? Yeah. Find that weakest point. Get that and sped up. Then you go find your next slow spot time. Speed that up.
Building a pipeline is an exhausting 24/7 operation. The crews work in 2 12-hour shifts with just a half-hour break for meals. Solitaire's head administrator, Hans Vierdege, runs the dining room just like the assembly line.
The whole thing we want to do with this is speed the service up so people can choose quickly.
It's all designed to get people back to work in a hurry. Meal choices are clearly displayed to help people make up their minds fast. And there's no coffee here to linger over.
Okay, so the reason we don't have coffee here is because we need to speed things up. We don't want people sitting here too long.
Back down on the assembly line, the factory crew is moving as fast as they can. But Keith has discovered a problem at the coating station.
The coating has been a problem. I mean, we have had issues with the injection mold polypropylene.
The coating station, the last stop before the pipe heads out onto the stinger and into the water, is slowing down the line. They're using a new plastic coating to protect the welded pipe joints, but it's taking twice as long as it should to bond. The competitive edge Solitaire gains by dropping 2 pipes at once is being wasted, and the assembly line is falling behind schedule. Keith is starting to feel the pressure.
If I don't produce and my team doesn't win, well, they don't fire the players, they fire the head coach. And I just so happen to be the head coach. And that could happen at any time.
Now it's Keith's job that's on the line, and so is Solitaire's. Just a few days into the job, she's delayed again, and the timing couldn't be worse. On the horizon, a storm is brewing. MV Solitaire has been laying down a gas pipeline in the Norwegian Sea for 3 days. But there's a slowdown in the factory, and construction boss Keith Hassage is under the gun.
It's very aggravating at times, unscheduled hiccups that come into play. There's always obstacles, and we overcome them at the end.
But Keith can't solve this one. A plastic coating that seals pipe joints won't dry fast enough. A section of pipe should be going underwater every 8 minutes. It's taking 15.
No, I know. Hard to find out.
Solitaire was supposed to finish this job in just a few days. With this snag, it might take another week. And things are about to get even worse.
We received another update on the weather. The swell is coming up that high and it's start pitching, so we have to monitor it. But it doesn't look too favorable for, say, Saturday afternoon.
A storm is brewing. Solitaire isn't worried. She can handle almost anything, but her stinger is a problem.
The waves out here can get pretty treacherous. But you can damage not only the pipeline, but you damage the stinger. If you damage the stinger, if the stinger was to break off, and I've seen them break off before, that is a major deal. That's months and months of your shut down, not making any money.
Hanging 140 meters off the stern, the stinger is the ship's most vulnerable part. If it gets battered by rough seas while holding on to 200 tons of pipe, it could snap right off. It's happened before.
When we get over 5 meters, we have to take the stinger out of the water.
If Captain Regtop has to raise the stinger, the job will come to a full stop. Even worse, the 1.5 kilometers of pipeline hanging off it will have to be cut loose. With bad weather forecast to hit in just 24 hours, Keith alerts the crew.
Anyway, that weather Saturday, that weather's supposed to kick up pretty good, and there's a possibility we have to put her on bottom. Expecting, about 4 or 5 meter seas. So we'll just see. Talk to Red. It may go away for all we know, but that's
gonna hang on to it.
Well, we're gonna try. It's coming out of the west-southwest.
If the pipeline is abandoned, they'll have to time it very carefully.
The biggest question about this is, okay, you can take this to extreme point and just hold on the pipe until you get to a point where you say, I've got myself in a bind.
It's a big job to cut the pipeline and then lower it gently to the bottom. Captain Regtop and Keith will have to make a decision before the storm hits. If they wait too long, it could be too late.
So you got to allocate about 10 hours of time ahead before the weather really hits hard in order to get the pipe on the bottom safely so nothing will be damaged.
It's a tough call. Abandon the line too early and valuable construction time will be lost. Leave it too late and the stinger could be destroyed. Their best hope is that the weather forecast is wrong. For the next 12 hours, the captain monitors winds and waves closely. They're rising rapidly. Statoil isn't happy about the change in weather either, but Ole knows that Mother Nature rules the seas.
The important thing now is that we respect the weather. It is what it is, and we need to make the right decisions in order to minimize the risk of damaging equipment.
With the weather growing steadily worse, Captain Regtop has to make a decision. He orders Keith to abandon the pipeline.
Well, abandonment, we're not just literally leaving it at somebody's doorstep. We're going to come back and pick it up. We're not going to leave it very far. It'll be handy for us to grab a hold of.
But for now, they're cutting it loose.
I'm not sure if I'm going to put the transfer on the stern side or the bow side, or three of them. Kevin, check it.
It's a frustrating time for the entire crew. They've had their setbacks, but this job was almost finished.
Pain that we could have knocked this thing out day after tomorrow easily, but now it's going to take a little longer. So that's the biggest frustration.
But right now, they've got to move fast. Abandoning a deep-sea pipeline is tricky. First, a cable is attached to the last pipe on the line before it's sent out onto the stinger. Then, the entire pipeline is lowered gently to the bottom. The hard part is making sure that the pipeline is laid down flat. If it lands on a ridge or boulder, it could snap. But the crew on Solitaire are pros. In less than 12 hours, the pipeline is safely abandoned. The stinger is secured, and Solitaire is ready to take on a major storm.
At this moment right now, we have the pipeline on bottom, and we've turned the vessel around
a heading that's favorable to ride the seas.
So we have to wait at least for as long as the forecast lasts, and that's about 4 or 5 days at the moment. It's very unfortunately. But there's nothing, can't change the weather.
It's a hurry up and wait job out here, and this is one of those waiting times. You have to be patient.
With a storm on the horizon, all they can do now is batten down the hatches and wait it out. No one knows when Solitaire will get back to work. A vicious storm in the Norwegian Sea has forced Solitaire's crew to abandon a gas pipeline on the sea floor. There's nothing they can do now except wait for the weather to improve. Foreman Kevin DeJean hates leaving a job half done.
It is frustrating because we like being in production and keep things rolling. When we do shut down for bad weather and stuff, it gets a little slow.
I have learned to be patient. I used to not be so patient, but in my time, I've learned to be patient. I've learned that it's very important to become patient. If not, you can make errors.
And with the factory shut down, there's nothing to do. Workers can't even enjoy a beer in the ship's pub. On this trip, it's a dry ship. There's nothing but TV to pass the time. After 5 long days, the storm finally dies down. At their daily morning meeting, Captain Regtalk delivers the good news.
The weather, it's 40 knots last night. It's coming down now, and for the next coming days it looks good, and the seas are coming down also.
Finally, it's all systems go. The Stinger is lowered back into the water. The abandoned pipeline is winched back up to the ship. Welders' torches are fired up again, and the assembly line gets back to work. They've got 7 more kilometers to go, and they lay that down in just 4 days. After almost 2 weeks at sea, the crew prepares for the final hurdle, dropping the last pipe into another 3 meter by 3 meter target box.
It's still a challenge to hit that small box again, of course.
The end pipe is fed out onto the Stinger, and the ROV tracks it down to the bottom.
It looks very promising. We are in width, we are a few centimeters from the target.
The ROV confirms the pipe's position. The end pipe has hit a bullseye.
Very nice. Unbelievable. It's good. In the box, but from the center line. So it's excellent.
The DCC is 12 centimeters.
It's 12 centimeters offline from the center.
This time it is inside the box and almost dead center. But Keith is a tough guy to satisfy.
It's pretty good. I mean, you know, I guess we could try to get it perfect, but I'll live 12 centimeters.
And so can the rest of the crew.
Yeah, it feels very well, yeah, for sure.
Relieved, I guess.
Relieved, yeah.
Once again, Solitaire has delivered. With the pipeline laid down, Statoil can now start the next phase of construction on schedule, installing the new subsea unit and drilling the first well. Within a few months, more natural gas will be on its way to customers in the United Kingdom.
And we are very happy that we have a successful ending to this. We have installed the pipelines successfully along the planned routes.
Down on the factory floor, Keith congratulates his team for a job well done.
Good. All right. Thank you, John. I'm happy now. I'm in a lot better mood now. You know. Congratulations, and job well done. We never expect everything to go perfect, but you just always wish it would. So it's this great sense that you get it done and you go on about the business and go on the next one.
Captain Regtalk is also proud of their work.
It always feels great. The whole crew actually is happy to finish the job. There's We try to do it as quick as possible in the best way. Especially this job is very challenging.
Solitaire is moving on to another job in the Norwegian Sea. Then she's off to Argentina and Brazil. The world's biggest, fastest pipe player has now added the title of most accurate to her status as heavyweight champion. Once again, Solitaire has proven that she's the best in the business. This ship is ready to rock. This is Stornes, the newest, most sophisticated rock-dropping vessel on the planet.
It's designed to beat the record.
Her goal is to make deep-sea history, working over a kilometer down to level the path for the pipelines that fuel Europe.
Everybody's eager to get to that depth.
We are nearly on the edge of the safety zone.
If she succeeds, Stornes will open up a brand new world of oil and gas exploration at the bottom of the sea. Stornes is the newest ship of her kind, working in the competitive world of offshore oil and gas. She's what's called a fall pipe vessel, one of only a few ships in the world built to lay rocks as a bed over which oil or gas pipelines are laid. Stornes can install rocks faster and deeper than any of her rivals. It's a point of pride for the man in charge of rock dropping, Dave McLeod.
Alan, we are going to KP 975, and you can give me a scan at 972. This vessel is definitely far above the standard. The setup of the whole vessel is very good. Other vessels, they need really good weather, maximum 2 or 3 meter waves. We can work up till 4 or 5 meters.
On the deck of the ship is a snake-like pipe. It acts like a funnel for the rocks that will be dropped to the bottom. The pipe is lowered through the middle of the ship all the way down to the sea floor. Rocks fed from the ship's cargo hold fall through the pipe, giving it the name fall pipe.
Yeah, we are ready to start launching.
At the end of the fall pipe is a large, yellow, remotely operated vehicle, or ROV, bristling with cameras and sensors to guide the pipe. The ROV has powerful thrusters, which move the bottom of the pipe along just a few meters above the ocean floor, giving it pinpoint precision when laying rocks. The fall pipe on Stornes can descend deeper than the world's tallest building is high, more than 900 meters. The ocean floor is not a flat beach. Underwater gas pipelines must negotiate rolling terrain and stretch across wide gullies. The stresses are enough to make the pipelines rupture. The rocks dropped by Stornes form supports in those gullies, so when the pipelines are laid, they remain secure. For Stornes' first deep water job ever, energy giant Shell has hired the ship to lay rocks at one of the most challenging sites in the world. The Ormen Lange gas field lies 120 kilometers off the west coast of Norway. Ormen Lange already supplies 20% of the United Kingdom's natural gas.
Tower.
Stornes is laying the foundations for 2 new pipelines, each 5 kilometers long, at depths ranging from 800 to 1,000 meters. In all, she will drop 450,000 tons of rock to complete the job. This project will establish the new ship's credibility, and she has just 2 months to pull it off.
I think everything is set up now, huh?
Yeah.
At the helm is an experienced captain who is eager to see how his new ship will perform on her first deep water mission.
It's a very big challenge for us that we have a new vessel. We are experimenting with a new vessel. We have a new crew and we all have to get familiarized with this new equipment. It's a big challenge for us.
No fall pipe ship has worked deeper than 1,000 meters. Stornes is built to break that threshold. If she succeeds, she will open up access to a whole other level of deep-sea oil and gas exploration.
We'll get confirmation on that today.
Les Sturgeon is the Shell representative aboard.
It's not decided yet, but there is talk of pushing development into deep water further north on this project. So should that development come, Shell would like to know that this vessel can work in those water depths.
The entire crew has an eye set on the deep water record, including Sergio Van Pelt, the assistant fall pipe superintendent.
All stop there, all stop.
You're talking 1,000 meters, so we're pushing the system to the limits then. Now we're going to be pumped up for it, of course. Yeah, you're trying to set a record, so everybody's going to be eager to get that to get to that depth.
It's just after 9 p.m. in the fjords leading to the small seaside town of Averøy, Norway. Stornes is here to pick up the first 27,000 tons of rock she needs to do the job. She is one of the largest ships to ever sail into this port. 175 meters long, 25 meters across, with a crew of 50. Stornes is the second largest vessel in her class. Being the newest, all eyes are on her until she proves her place as the world's best rock dropper. The local harbor pilot comes aboard to help bring in the huge ship. On the bridge,
Hi, welcome. How are you? Hi.
He is now in charge.
Going straight alongside?
Yeah, this one is mooring on starboard side.
All right.
Full speed.
Sir, we're going to request the mooring crew.
Yeah, okay, Marlon, thank you.
A mooring crew sets out from shore to fight the elements and tie the ship down. It's freezing cold and blowing snow, typical for January.
Marlon, slack a little bit.
Buffeted by waves, the crew struggles to get the huge ship snug against the pier. Right next to the docks is a huge quarry which will feed Stornes her load of rocks.
Okay, so thank you. Vessel is upright.
Good seeing you again.
Good seeing you.
Now it's time to start loading the rocks. The 3.5-ton hatch on the first giant hold opens. The conveyor belt from the quarry moves into place. A backhoe and bulldozer work together to dump rocks onto a conveyor that stretches across the jetty to Stornes. Stornes can hold a whopping 27,000 tons of rocks. As each hold fills up, the weight is enough to actually bend the hull of the ship. So they follow a specific loading sequence that reduces that stress and prevents the hull from cracking. The rocks are granite and custom cut to no more than 12 centimeters across. The loading continues non-stop all night at a rate of 1,800 tons an hour. While rocks tumble into the mammoth holds, deck engineer Pedro de Freitas is racing against the clock to load supplies.
I'm only going to be until midnight, but I'm sure my reliever is going to keep all night doing it.
Time is money. Once Stornes starts her job, overlooking even the tiniest item could prove critical. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board.
12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a mountain of rock is now on board. 12 hours later, the Arctic winter sun still isn't up, but a
Deck, Captain.
Go ahead, Captain Ed.
Yeah, JR, as soon as the pilot has arrived, he can let go the gangway and then the forward and aft springs.
On the bridge, Captain Ed Noctegal gives the order to cast off.
Pilot on board.
Okay, thank you. Foreship, off ship, let go, bow spring and stern spring.
The captain leads the rock-heavy ship out past the treacherous shoals at the mouth of the fjord and into open seas toward Ormen-Lange. Loaded to her maximum, Stornes will now attempt to lay 27,000 tons of rock 1 kilometer down on the bottom of the sea. The fall pipe ship Stornes is en route with 27,000 tons of rock. Her job is to build supports that will level out the ocean floor for a new branch of gas pipelines, the latest in a web of subsea pipelines that fuel Great Britain. The ship will drop these rocks and then come back to port, over and over, round the clock, until the job is done, about 18 times in 2 months. Stornes steams full speed for the Ormen-Lange gas field, 6 hours away. She's left port 2 days ahead of schedule, but the weather waiting for them at the worksite threatens to stop them cold. Captain Ed Noctegal knows it all too well.
We have the conditions when there is a depression starting from Greenland or from America that comes to Europe. It has the possibility to build up the waves.
If waves exceed 5 meters, the fall pipe cannot be deployed. Les Sturgeon is the shell rep aboard.
We are limited to the weather conditions we can work in. We have something called a significant wave height, and the knockoff is about 4.5, 5 meters.
Once they get to the site, decision-making goes to the fall pipe superintendent, Dave McLeod.
It's going to be extremely difficult. As he states, at the moment we have wave heights 5 meters. You can see the rolling of the vessel. I give it a 50-50% chance.
As worried as he is about the waves on the surface, Dave is even more concerned about the strong underwater currents of the Norwegian Sea. Surface currents move in one direction. Those in the deep move in another, which can twist the fall pipe into an S shape, making the entire operation much more difficult, sometimes impossible.
I really hope everything goes well. If I have the impression the weather will force us to stop because it will give us too much problem, I will not take the risk to go down. It has to go the first time right. If it goes wrong, then we have big problems.
With Stornes steaming out to the site, Chief Engineer Mark van der Stok and Chief Officer Riemer van Doorn head below decks to inspect the ship's massive conveyor belt system.
Hello, Bridge, Riemer.
Riemer, Bridge, come in.
Okay, JR, can you discharge from the port side tunnel belt, please?
It's one of a kind, brand new, and it's the linchpin to the fall pipe system's success.
Okay, we're going to discharge the port side belt.
They test the belts with a small amount of rock.
Please, so I can check if everything is okay, if it's falling from the gate.
A complex conveyor system runs almost the full length of the ship. This moves the rocks out of the holds and into the fall pipe. In all, there's almost a kilometer of conveyors running up and down the ship.
Okay, thank you. Can we do now the starboard tunnel belt, please?
Hey, Riemer.
Jay, this one we need to put a new valve, eh? Yeah, this one we have spare.
If any one of these belts gets damaged, the whole system shuts down.
For example, there can be a metal plate coming loose in the cargo hold and can go on the belt, can cut all the belts. Hydraulic spill can happen and a lot of things can go wrong.
Well, there are so many moving parts and so many things which are still obviously new. But yeah, as long as it's machinery, everything can and eventually will break down.
For their client, Shell, that's not an option. In just 2 months, another ship is scheduled to lay pipe on top of the rocks Stornes has been contracted to drop. Delays here could cost millions of dollars if the job isn't done before the pipe-laying ship arrives. Stornes must succeed. 6 hours later, Stornes arrives at the job site. Amazingly, the weather has improved. The seafloor here is rugged. The crew is eager to get to work leveling it out by deploying the fall pipe and laying some rocks. First step, launch the device fixed to the bottom end of the fall pipe, the remotely operated vehicle, or ROV.
Good to go.
Okay, Bridge, we are ready to start launching.
Stornes has a trap door in her hull. It's called the moon pool. It opens to reveal a gap large enough to drop an 18-wheeler down through the belly of the ship. The ROV is equipped with 4 cameras and 3 sonar sensors that are the crew's eyes to the ocean floor. Controlled by pilots on the ship, it has thrusters, small powerful propellers to maneuver it. From a height taller than the world's tallest building, rocks will fall through the fall pipe onto their precise target. Give or take just 20 centimeters. This ROV has never been deployed in waters as deep as this, and the crew is eager to see how it will perform. The fall pipe uses a series of open cylinders called buckets, held together by chains. The buckets fit together like Russian dolls and stretch apart as they drop through the moon pool. At full length, the chains alone weigh 17 tons, and the fall pipe can be a staggering 1,000 meters long. Stornes can deploy her flexible fall pipe in less than 3 hours. Older systems on other vessels take 6 hours or more. The entire operation is controlled from a location called the dump desk. It's the ship's nerve center, and Dave McLeod is at its hub. They're keeping a close watch on the new ROV. 100, 200, 300 meters. Suddenly, a problem. Sergio Van Pelt heads to the moon pool and discovers it's a big one.
Now we have an electrical problem on the ROV, so we're trying to figure out if we can sort it whilst the ROV is down in the water. If that's not the case, then we'll have to recover the buckets, and after that recover the ROV and see what kind of problem we have. Solving the problem might be a big deal.
The brand new ROV is completely dead, and they're only 1/3 of the way to the bottom.
So what we're trying to figure out is if we can resolve the problem on software-wise on the control panel on the bridge. Hopefully we can get it working again.
If the dump desk crew can't solve the problem, the fall pipe will have to come back up to the ship. And that's not in the schedule. Once the ROV fixed to the end of the fall pipe is deployed, it's meant to stay down until all the rocks are dropped.
We will take up the arms and we keep it here for a few minutes before we go down.
Okay, copy that.
They switch power to one of the other umbilical cables, the lifelines between the ship and the ROV. Suddenly, the ROV comes back online.
Everything is switching.
The glitch seems to be fixed.
Okay, Dave, copy that. Continue launching.
Minute by minute, meter by meter, the fall pipe is lowered almost a kilometer into the ocean. Then, at 900 meters, another blackout. The ROV once again goes dead.
The launching went very successful. Just when we were about to start working at 900 meters, the ROV suddenly became dead, meaning we lost electronics on the ROV. We have an earth fault somewhere in the system.
The pilots scramble to recover communication with the ROV. Meanwhile, Chief Deck Engineer Fred de Boer racks his brain.
That's what you're giving me to the midship?
He suspects there is a problem with the second umbilical cable.
I think our umbilical is damaged somewhere. I don't know where. It's on the tip.
On the first ever deep-sea deployment of the fall pipe, the entire operation is dead in the water, and Stornes hasn't even dropped a single... It's day 2 for the fall pipe vessel Stornes on her first ever deep-water job. Her brand new ROV is malfunctioning, lifeless, and the mission is at a halt. Her task is to drop thousands of tons of rock down a long pipe to level the ocean floor for a gas pipeline expansion. The crew switches over to the third and final set of communication lines on the ROV. The cameras are offline, but other sensors are working and feeding sonar data back to the ship. It's time to make a decision. Pull up and go back to port or keep working at the bottom of the sea. Dave McLeod, the man in charge, has experienced failures like this before. He knows they can safely operate with the sensors that are working.
Just give it a try. We start everything up. We just have a look for half an hour to see how it goes. And keep an eye on the benders.
Okay.
If he's wrong, he's wasting precious time on a job where time is the one thing they don't have. Despite the technical setback, McLeod keeps his cool. It's a new ship, and he knows things can go wrong in the first few voyages.
In normal life, it would be quite expensive. However, we have calculated with the start of a new vessel, you will have some problems.
Assistant Superintendent Sergio Van Pelt works with the ROV pilot in pitch black water. It's hard, but they navigate with sonar alone, seeing the bottom with sound. One collision with the sea floor and the operation is done. There is no backup.
How far down you need to go? Okay, come another 10 meters to the south, please.
Success. Without video, the skilled crew manages to guide the fall pipe within mere centimeters of the exact position. Dave McLeod's experience has paid off.
Exciting, the first rock at 900 meters. Quite happy with that. So I hope the problems are solved. Not 100% confident yet, but let's hope we can continue working. Now the difficult task starts to get all the rock in the right place.
Before a single rock can be laid, the ROV does a sonar survey of the bottom to confirm that their existing map of the sea floor is correct. Surveyor Bartosz Kowalczyk knows there's a real challenge here.
Ormenlange is very strange environment. It's not completely flat like in the UK. In here you can see plenty mountains, plenty deeps, a lot of different features on the seabed. This is extremely difficult. End of survey.
The critical job begins with the data the survey team now gathers from the ROV.
There's survey on the location 5025 south, and I would recommend to use the aft one.
Okay.
Right?
Oh yeah, thank you. The latest survey? Yeah, okay.
Chief Surveyor Robert Kroll takes the data from the ROV to map out where the pipeline will eventually go and where the rocks need to be laid.
There's no pipeline yet, so we design our own grid over the working area, and that is just a square grid of lines crossing each other, and we take one line as the main line, which is always the long line, and we navigate on those lines.
All the while, Stornes is kept in place over the worksite by a system called dynamic positioning. GPS communicating with the ship's thrusters ensures that she doesn't move more than 50 centimeters, even in 3-meter waves. The system is among the most precise in the world. The data is confirmed. The site is about 70 meters across and 40 wide, with depressions as deep as 3 meters.
The fear is on.
The fall pipe's job is to fill in an uneven area of the ocean floor with tons of rock. The rocks provide supports for the pipelines that will be laid here in 2 months. Without those supports, the gas lines could rupture.
I need you to come 50 meters to the east.
50 to the east.
Yes, and then stop on track.
Stop on track.
It's quite amazing that we can achieve that at this depth. It's interesting to see that it actually works.
To KP 975.
Despite problems with the ROV cameras, the dump desk uses the sonar sensors to lay rocks in exact position. The complex web of conveyor belts transfers tons of rocks out of the holds. They feed directly into the fall pipe, which dangles hundreds of meters below the ship. The rocks leave the mouth of the fall pipe and fall to the ocean floor to fill this depression, exactly where the future pipeline will go. Every hour, the weight of 10 locomotives pours down the fall pipe. But problems with the ROV are still a big concern. A few hours later, their worst fears come true. Another complete failure. All communications with the ROV are lost. For the second time in as many days, work aboard Stornes grinds to a halt, with no quick fix in sight. The fall pipe vessel Stornes is on a critical job, laying rock on the ocean floor to support a new gas pipeline that will fuel Britain. Almost a kilometer underwater, mere meters from the sea floor, her brand new ROV is completely dead, putting their multi-million-dollar job at risk.
Dave, Fred?
Operations Chief Dave McLeod declares its situation critical. The ROV and the entire fall pipe have to come back up on deck. Dave's right-hand man, Sergio Van Pelt, thinks Stornes might even have to go to shore to fix the problem.
Most of the problems we can fix ourselves on board. This seems to be a little bit bigger problem or a deeper problem. So we might have to call in a technician from the manufacturer. If that's the case, then we're going to be going in 2 days early. So we're going to be losing 2, 3, 4 days production time. That's not good. That's not good. That's not what we want.
So if we switch off and just get the cable out and then switch on again, let's see what's happening.
It's taken 3 hours to bring the complete fall pipe back on board. Now Chief Deck Engineer Fred de Boer and the ROV pilots hope they can find the problem.
What this means, this cable. The problem with the ROV at this moment is that we have a line insulation problem. So this means that somewhere is a shortage. So it can be water ingress or maybe dodgy cables. Because we are at 800 meters water depth, there's a lot of pressure on. So we're going to do some troubleshooting and going to do some measurements. Because I don't want to do this again.
Hoping to be way ahead of schedule, Stornes could be set back days.
And maybe we have to check the rotating junction boxes as well. Maybe there's moisture inside.
The team finally comes up with a solution. Rewire the ROV.
We think we got the problem solved, the moist connector. And as soon as you get water into the contacts of the electricity, then the system just shuts down.
They re-insulate all the wiring and move the wires away from the powerful thrusters that propel the ROV.
These cables that are damaged, there are 2 cables that are near the thrusters. We have to reroute the cables so it has less problems with the shaking vibration of the motors.
6 hours later, they've completed the rewiring job and the ROV springs to life. It works on deck. But will it work nearly a kilometer down at the bottom of the sea? Dave gives the go-ahead to lower the fall pipe and ROV again. He hopes the problems are solved. He can't afford to lose any more time. The news is good. All functions of the ROV are working perfectly. The fall pipe is deployed to the correct position, and 4 hours later, the job at the first site is complete. Stornes moves on to her next work site just 2 kilometers away. This is the big one. They will offload almost 10,000 tons of rock on this 120 by 50 meter site at a full 900 meters down. The job starts with an exacting survey.
It's a virgin location. I'm looking forward to this one. It's not an easy one, but hey, we're working at 900 meters.
Going forward to 976.
A little bit to the left.
A bit to the left.
And you can come forward.
Forward.
Slowly forward.
Slowly forward.
Possible. This is indeed a counterfill in an area that is at the moment very uneven. So we have to make it reasonable flat, and that is quite difficult.
Got to reset it up.
The crew must remain totally focused in this mountainous terrain to avoid an underwater collision.
A little bit to the left, Mark.
A bit to the left.
Levi, can you come 2 meters south?
2 meters out.
Okay, Mark, you can come to KP 975.
The new wiring on the ROV is holding.
Offset is completed, Bart.
Thank you. Okay.
The technical survey is complete at the second site.
Starting about. Keep clear.
Conveyors from the holds now move rocks up and down the ship, leading them to the hopper that funnels into the fall pipe. From there, they drop 900 meters, more than twice the height of the Empire State Building, to a precise position on the ocean floor.
Tower, the bridge. How is the position, Bartos? Okay. It's okay? Can you come 2 meters out? Just 2 meters out, please.
Surveyor Bartosz Kowalczyk carefully watches the ROV's readouts, fearing another failure.
What do you want to do next, Peter?
Well, after the survey, we track through the mainfill area, and we just do a little sprinkle on the corners. And the plan is that we touch the corners. Here we got the profiles.
There's still 11 meters to go to the north.
We made it easy for you.
Of course.
Just fishing,
of course,
finishing off.
that's what I like. That's what I like. Give me the easy jobs.
We'll do 60 tons here, and then we'll land on the total south.
Finally, Dave McLeod is feeling like things are on track.
Progress is going very well. I'm very happy.
Over the next day, rocks are deposited on precise targets throughout the site.
We keep it here just a little bit longer, and then we go again forward a little bit for the ditch to the left.
The crew can take their first breather, and that includes workouts, haircuts, and emails home. The ritual of mealtime holds crews together on all ships. On working ships like Stornes, it's then that the crew finds time to talk about things other than rocks and ROVs.
Can you raise the ROV just 2 meters?
Within hours, the undersea depression at the second site is filled. The holds are empty. No more rocks. Time to pull up.
Ready for recovery.
Okay, Sergio. Starting recovery now.
Copy that.
But just as the fall pipe is being retrieved, a new problem, 65 meters from the surface.
There's a lot of current.
The current is carrying the fall pipe away from the ship. smashing it against the sides of the moon pool. Stornes moves with the current to center the fall pipe, but that's carried her close to the safety zone of a nearby drill ship. Captain Ed Nachtigal knows the rules. He can't enter the safety zone without a permit, but he also wants to get the fall pipe back on deck without damaging it. The captain monitors the delicate situation from the deck.
We are detecting the ROV now and the fall pipe. We are nearly on the edge of the safety zone, and basically we're not allowed to enter the safety zone.
The ROV is stuck, dangling 65 meters from the bottom of the ship. And with strong currents bending it away, there's no way to retrieve it. Stornes is one of only a few ships in the world that can level the ocean floor with rock, drop down a flexible pipe that is 2.5 times the height of the Empire State Building. But now, that pipe is bending precariously in the current. Retrieving it has brought Stornes dangerously close to the safety zone of a nearby drill ship. Chief Deck Engineer Fred de Boer is fighting the current to reel in the fall pipe quickly. But it's smashing against the side of the moon pool and can't just be dragged up.
There's a lot of current, so we have now a little bit of struggle trying to recover. So that's a bit of a problem at this moment, so we have to look how we deal with this.
But then, the current subsides, just enough to haul the remaining pipe and the ROV onto the ship. Now it's a race against time. Move away from the other ship, return to port, load up with more rocks, and attempt the final, deepest, and most difficult drop yet.
That's okay.
6 hours later, they pull into port and immediately get to work reloading another 27,000 tons of rock. At daylight, the crew quickly takes up the mooring lines, and Stornes pulls away from the quarry. Then it's back out toward the Ormenlange gas field, 120 kilometers away. 50 kilometers from their work site, the unforgiving Norwegian sea crashes in on her. 4-meter waves rock Stornes. Her working limit is 5. On the bridge, Captain Ed Nachtigal keeps a close watch on the waves. The computer indicates they are within the working limit of 5 meters, for now. Despite the rough seas, they reach their new deepest site on time. Dave McLeod gives the word: lower the fall pipe.
Hello, Mr. Kasaka. Yeah, okay, yeah, be careful of your fingers.
They try to work quickly to get the job done before the weather shuts them down.
And let's try a reverse, please. Reverse. Same offset, same speed.
You go north again, speed setting 10.
The ship's thrusters are powerful, but no match for the power of the sea.
Our bow thrusters are having a hard time.
Yeah, that's okay.
The weather threatens to get even worse. But despite the heavy seas, Dave wants to push the new ship to her limits.
We have a weather forecast showing that we'll get waves up to 7 meters. I know that it's not workable anymore. But can you still work at 4 meters or 5 meters or maybe 6?
Rocks continue to pour down the ship's fall pipe. The next day, they are halfway through the job. Dave McLeod anxiously watches the seas from the bridge.
We're pushing the vessel. We want to see the limits, but of course we have a safety margin. I cannot just go over the limits. At the moment we are at a state that it's just getting to the end.
Stornes has run straight into the realities of rough offshore work.
And as you can see, the weather is picking up. I think we are almost to the limits of making a good rock berm.
Yeah. I think we are on the limits as well, Barend, yeah. With the DP. It's still tracking, but it's not so reliable anymore.
With waves as high as the deck pounding them, Dave makes the call.
Okay, Serge, it's going to be the last run. After this run, we're going to do one more survey run, and then we bring up the system. Okay. Okay.
They'll have to wait out the weather and come back.
Okay, one more scan on the aft, please. Feeder is off.
There's no possibility we can go now to deep water. Absolutely not, no.
Okay, JO, when you're ready, you can stop your system and wait for the tower, and then they can close all the sections to make it watertight.
Okay, that's it.
You can retract the belt. We'll stop the system, then you can retract the belt only.
Okay, copy that.
Thank you.
Okay, system stopped. Start recovery.
Out on the deck, Sergio and his team secure the fall pipe as it comes up, getting ready to face the brunt of the storm.
Come on, Robert, put some gas in that.
Now a new problem. The ROV is tangled in its umbilical cables, 20 meters down. It's stuck, and it can't be raised or lowered. The huge robot swings precariously as the ship is hammered by waves with no solution in sight. Hounded by weather in the middle of the Norwegian Sea, the ship Stornes now faces a big problem.
We have 3 cables hanging on the ROV, actually holding the ROV, and one of them sort of got a hold of the ROV while the other 2 were slack.
Her ROV is stuck just below the ship's open moon pool, and it can't be reeled in.
We don't want that situation, that way the ROV comes into an angle and we cannot recover it properly.
The ROV has 3 umbilical cables which the crew uses to keep it level. Now one is tangled. Using the other 2, they manage to get the ROV level enough to free the tangle. They gently haul the ROV into the moon pool. The crew lashes it down for the rough ride back to shore.
We finished. Everybody in the accommodation. I'm going to see if everything's secure.
Yeah, okay.
Stornes is daunted, but not defeated. She has proven that she has what it takes.
It's absolutely brilliant. It's the first time we have been to 900 meters.
Stornes has successfully filled her first 2 sites at a speed no other fall pipe vessel can match, all at depths of almost 1 kilometer.
The performance of the vessel is really much better than the previous vessels I've been on. The whole rock installation equipment is so good. Yeah, I'm extremely happy.
So we're making full speed now, 14.5 knots.
She heads for port to reload with rocks for the next part of the job. She'll finish this project on time over the next 2 months, dropping 500,000 tons of rock in the Ormen Lange gas field. Now the pipeline can be laid on the level sea floor. And if she can work in the treacherous mountain ranges of the Norwegian Sea, Stornes has proven she can work anywhere.
Start of survey.
The best of all, is just to stand up with your chest out and say, yeah, we did that, nobody else can do it.
Her crew is proud of her and the critical job she does.
Hello, Noel, Rimmer. Yeah, of course. We always like to go to the highest output, the deepest water. You feel great. You feel like I'm the king of the rock dumping industry.
Stornes works day and night to level the bottom of the sea for the pipelines that fuel Europe. And thanks to this ship, new untapped resources below the seafloor are now within reach. She's one of the largest subsea construction ships in the world, North Sea Giant.
This boat can do anything.
Her mission? To build a factory 300 meters below the surface.
These modules are basically like Lego.
It's a job that requires special cranes.
Come down 1/2 meter.
Robotic submarines.
I'll stop.
And nerves of steel.
It's too narrow, isn't it?
Billions of dollars are on the line.
This is the most critical phase.
On a project the world has never seen before. When it comes to subsea construction, nothing matches Norway's North Sea Giant. Her specialty? Installing massive components for oil and gas facilities on the ocean floor. She stands 46 meters above the water and stretches 161 meters from bow to stern. A state-of-the-art propeller system enables her to turn on a dime. And she has 7 cranes for lifting and lowering cargo into the sea.
The North Sea Giant is the undisputed flagship in the North Sea shipping fleet.
Captain Bjorn Fjolsbach leads a team of 114 crew, contractors, and technicians on the Giant.
Its capabilities and equipment are unrivaled.
For the past 8 months, North Sea Giant has been working off the coast of Norway, in the Norwegian Sea, on the most ambitious undersea construction project ever. The world's first underwater natural gas compression station, 300 meters below the surface. This subsea factory will be hooked up to 11 existing natural gas wells. The compressor will add pressure to the gas flow so the wells can be productive for an additional 20 years.
The purpose of the compressor station is to take more gas out of the reservoir.
Morten Persson has spent the last 4 years on this project for Norwegian energy giant Statoil.
Without the compressor station, we would recover only 60% of the reservoir.
It's the high point of his career.
This is the largest subsea project ever. The size of the subsea compression station covers almost a football field. So for the subsea industry, this is really a step change.
A $3 billion investment expected to yield $12 billion in additional natural gas that will be transported by pipeline to Europe. The compression station has 29 modules. Now it's time for North Sea Giant to install the final component in the job. The world's first subsea compressor. 4 stories high, it weighs 388 tons. It's the biggest, heaviest, and most important module in the entire operation.
There are a lot of vessels then that might install 400-ton modules. But the North Sea Giant can do this in 4.5-meter high waves.
Right now, the compressor is in a hangar in Kristiansund, Norway. After loading it on deck, North Sea Giant will sail 138 miles offshore to the Åsgard gas and oil field. Then, lower the compressor deep below the waterline into place on the sea floor. But before the ship can bring the compressor on board,
let's make it 4 on the quay side.
A team of welders must clean up the deck. Cutting away scrap bits of steel lashing left over from previous transports.
Right, Marty, come back.
Deck foreman Jamie Bolans, known to the crew as Jama,
That's a good speed, Merrick.
keeps one eye on the work and the other on the clock.
You ready, mate? Oh! You ready? How much longer have you got left for this now? The biggest problems on the back deck is slip, trips and falls. We have to make sure we gouge all the deck down, getting rid of all the trip hazards. Yeah, then we'll just swap over here.
As welding continues, North Sea Giant arrives at the pier. The rush is on to get the compressor on the ship before nightfall.
700.
The first load to come on board is a giant frame weighing 50 tons.
Easy on your tagline, Adam, not too quick.
This will be the compressor's parking space on the ship.
As it's coming round like that. Okay, Merrick, start coming down your line, we'll get a better look.
Meanwhile, it's time to move the compressor out of the hangar. To move a load this big requires not one, but 2 special transporters, which are operated by remote control. Their pilot is Kjetil Svegen.
It can drive the forward, backward, diagonal, circle, turn around its own axis.
Each transporter has 48 wheels.
Right now we are using 24 axles and it has a capacity of 48 tons per axle.
The compressor needs to move just 300 meters to the pier. But with almost 400 tons on board, the transporter's top speed is less than 2 kilometers per hour. That means it will take the next 45 minutes for Kjetil to get the compressor safely alongside the ship.
It's a hell of a good job and there's not much operators in the world that does this.
Each wheel on the transporters can rotate up to 260 degrees, but the turns are still risky.
A critical point is the hydraulic setup of the suspension. If that suspension setup is not correct, then the module will tip over and fall off the trailer. So that's the worst case scenario.
Back on North Sea Giant, the crane finishes bringing the smaller equipment on board. Now for the compressor. To lift a load this heavy, it takes a special crane. They call it the SHS, the Special Handling System.
You see the SHS system? That's what picks up the module, and that is state-of-the-art equipment. One of the only ones in the world that does the job we do at the moment.
The SHS is designed to carry loads up to 420 tons. What makes it unique is that it can work in higher waves than any other crane on Earth, up to 9 meters. But the SHS is located on the port side of the ship, so the first step is to turn the ship around. Just 10 minutes later, North Sea Giant is back alongside.
Mission accomplished. I'm waiting for the ABs to call up every second now to say that we're all fast.
Kjetil brings the compressor into position. For the first time in 3 hours, he can relax. Now it's Jama's turn to move the compressor.
SHS deck.
Deck.
Can we level up the sheave, please?
The SHS is rigged with the load.
Here we go, on the move now.
It's time to bring this massive cargo on board. This is the heaviest load the SHS has ever lifted. The challenge will be to do it safely, without damaging the ship or her precious cargo. On the west coast of Norway,
here we go, on the move now.
One of the world's largest subsea construction ships is lifting her heaviest cargo ever.
Can we level up the sheave, please? We have to make sure the compressor is in a level position before we start taking it on board. It's coming down, please.
The compressor weighs almost 400 tons, enough to tip the ship on her side.
That wouldn't be too good.
On the bridge, the captain initiates the ship's ballast system. This enables the captain to balance the ship as the load comes aboard.
We have 4 of ballast tanks with pumps that move water in between them. So when we take on the load on this side, we move water to the other side and the boat stays upright.
Although the ballast system is automated, the captain will be taking no chances today.
As always, things can come to a stop, and it's better to have manual control here, and that's what the mates are doing while I oversee the entire operation.
As the special crane picks up the compressor, the ballast tanks fill with 500 tons of water, counterbalancing the load to keep both the ship and the crane steady. Unlike most cranes, the special handling system does not extend its arm. It simply pivots to deliver the compressor into the frame. JAMA returns to the ship to supervise the landing of the compressor on deck. It needs to land in the special cradle that has been bolted into the deck of the ship.
Okay, SHS, you're a couple of meters away now. He's going to come down on the compressor itself and leave their CGF frame where it is. Yeah, copy that, mate. Carry on down.
Roger, coming now.
So far, so good, no problems at all, nice and steady. Good operation awareness from the supervisor upstairs. You'll see the compressor coming down and the bumper bars, it will settle into place. Okay, when you're ready to come down on the main lift.
Locking pins from the cradle slide into the compressor's struts. It is now virtually part of the ship and won't slide around in heavy waves. With the compressor on board, JAMA's crew calls it a night. The next morning, it's time to leave the dock and head toward the Asgard gas field.
I'll just come a bit more astern, and then we'll go out into the bay.
Along the way, they will measure the wet weight of the compressor in the outer harbor. The compressor will be lowered off the side of the ship, long enough for its hollow, perforated frame to fill with water. Then, the crew will test that the Giant's special handling system is strong enough to pull the waterlogged compressor back up, just in case it ever has to be recovered.
We'll go away from the berth, out into the basin here, and lower it down, say, 50 odd meters. Wait until all the members are water-filled, and pick it up again.
The compressor is not the only thing taking the plunge today. 2 submersible robots called ROVs, remotely operated vehicles, will also be making the trip to keep an eye on the compressor. The ROVs have their own cranes that place them in the water, making sure to keep clear of the hull. The submersibles are operated from the ship's mission control room. With just a few joysticks, ROV pilots can control their cameras, navigation, and robotic arms. On the bridge, Captain Fjolsbach has brought North Sea Giant to the test location in the outer harbor. It's about 70 meters deep here, perfect for filling the compressor. With the ROVs in the water and the ship in position, the SHS crane can start the lift. But just as the compressor begins its ascent,
As the plastic, the perspex seat's lifted there.
a loud grinding noise brings the lift to a halt. Mitchell Pike is the lead engineer for Statoil.
Something has got caught and it shouldn't have happened because they are getting a live response up in the cabin there with what the weight is, and they know it shouldn't be going above 388, so it shouldn't have happened.
JAMA spots the problem. One of the cradle's locking pins didn't fully retract, so it was scraping against the compressor as it rose.
We just had one small incident here with the sea fastening frame that you can see in front of us. We've inspected the module. There doesn't appear to be any damage. Everything's looking good and we're still safe to go.
Once the compressor is installed out in the gas field, it will need to be retrieved for maintenance within 5 years.
These modules are basically like Lego and they're designed to come up and down when they need any kind of work done on them.
But when the compressor goes underwater, it will put on some weight.
When it goes into the water, you can see the black dots all over the structure. These are letting water into the structure to make sure it doesn't implode when we send it down to the seabed.
The compressor is built to survive a trip to the bottom of the sea. But no one knows if North Sea Giant is strong enough to bring it back up. If she's not, then both the ship and her cargo will be stuck right here. In Norway's Kristiansand Harbor, the crew of North Sea Giant is checking the weight on a massive gas compressor module 50 meters underwater. The compressor will be the last critical piece for the Asgard subsea compression facility. But before it is installed, crane operator Don Hamilton and the operations team want to know they can bring it back up for maintenance.
We've never actually recovered a module yet, so we need to know for our benefit what it's going to be when we bring it out of the water.
Because the module's hollow tubes and struts are perforated, it takes on water below the surface. That could push the Giant's special handling system beyond its 420-ton limit.
So Johnny, what's the current weight down there?
We've got 303 tons currently, subsea.
The water is obviously coming into the structure, and so far we've just under 30 tons of water in there.
If the wet compressor weighs more than the SHS can lift, then it will be stuck on the bottom of the ocean, and a $3 billion compression station will be useless.
All right, well, let's give it another 15 minutes or so, and we'll have a chat with the captain on whether or not we try and give it a bit of a shake.
After an hour, the compressor's hollow struts are filled with water. Now comes the stressful part.
Setting 0 point. Winch on the move.
The crane measures the weight as it pulls the module back to the surface.
We're looking at how fast the water evacuates from the module, just to understand the weight variation of the wet compressor versus a dry compressor.
In the crane control room, the compressor's wet weight is revealed: 419 tons.
We're very happy with the test today. This is successfully proven that we're under the 420, but only by a whisker. We can still use the SHS to recover this module in the worst conditions we expect at Åsgard.
It's a big relief. With the compressor back on board, Captain Fjolsbach plots a course to the work site.
We'll now make our way out to the Åsgard oil field, and it takes us about 11 hours or so.
As the ship sets out to sea, Morten is worried about the weather.
We will have a bumpy ride out because there is a little gale coming in, waves of 5-6 meters, but that will be great. And then we will go to the field and do checking out on the pipeline.
The next morning, North Sea Giant reaches her destination, 222 kilometers off Norway's west coast. The ship comes to a stop above the Åsgard gas and oil field.
You just be careful there.
On deck, Jamma's crew fills a basket with tools. The ROVs will need them to close a valve on the pipeline, making it safe to install the compressor. This basket needs to go to the sea floor, but there's a problem. It's a windy day with 5-meter waves, too high for the utility cranes. So the gear won't be going into the water on the side of the ship. Instead, it will be going through the ship by way of the moon pool.
The moon pool is situated in the center of the ship. We can launch and deploy modules, even up to 70 tons in real high waves. From a subsea construction point of view, the system is ideal.
The moon pool stretches 10.7 meters from the deck all the way down to the bottom of the ship's hull, providing critical shelter when the seas get rough.
Can you send a crane over for me, mate? Empty hog. Now, this machine here is about to go down the moon pool when we're ready. Just setting up a few things here. Basically, the tools in here get connected to the ROV.
Despite all the ship's technological marvels, it still takes some muscle to get the crane's hook attached to the basket.
Just going to take the chains off now, mate, and start skidding the basket in.
The tools are ready for their 300-meter descent to the sea floor. Thanks to the moon pool and its crane, this gear can be delivered even in high waves. But the compressor is a different story. If the wind stays this strong, North Sea Giant may have problems delivering this billion-dollar payload to the sea floor. And there is only one way to find out. One of the world's largest subsea construction ships has arrived at the Åsgard gas and oil field, 222 kilometers off the west coast of Norway. North Sea Giant's mission: to install this massive compressor unit on the sea floor, 300 meters below the surface.
I believe that the subsea compression station of this range is comparable with the developments in space. We can't get to this plant to this depth with divers, so it all has to be installed and controlled and operated via controlled robots, the ROVs.
And today, the ROVs, remotely operated vehicles, have a critical job to perform. They need to shut off the flow of gas through the pipe directly below the ship. Only then will it be safe to lower the compressor. It will take all 3 submersibles to do the work today. Technician Stein Atle Sundland is in charge of the ROV bay.
We're going to launch the ROV now. We're going to operate some valves on the seabed. So we're going to launch the torque tool, the big torque tool on the back deck. And then we're going to operate the torque tool with the ROV.
Each ROV is equipped with 2 robotic arms, one for heavy-duty lifting, the other for intricate work. The morning's high winds have died down, making it safer to lower the submersibles over the side of the ship. They are steered from this mission control room. David Jackson is an ROV pilot.
Yeah, we'll fly with this main joystick here, which moves lateral in both directions, forward, backwards.
It's really like a big PlayStation.
To close the pipeline's valves, the submersibles take some tools from the basket that was lowered down through the moon pool. 300 meters below the surface, it is pitch black. The submersibles provide the only source of light.
Okay, support one control.
Construction supervisor Andrew Shuttleworth is in charge of the operation.
We're going to step over now to the job and we're going to close the valve. The idea of this valve is that we'll be doing a leak test, and this is going to act as a barrier. It's going to shut off an area that we don't want anything passing through.
On land, closing this valve would only take a few minutes, but closing one at the bottom of the sea by remote control is like performing construction in space. To turn the half-meter valve, the ROVs need this, the torque tool. Too heavy for the submersibles to carry, it's the last thing lowered down by crane from the ship.
Okay, if you can get your grabber ready, and grab on, and then we'll just continue to lower down with the crane. Just locate the valve.
The ROVs will steer the torque tool into place, but they aren't alone down here.
Fish do cause us some issues. They can get in the way when we're trying to view things, and they also have an effect on if they flounder the vehicle. A large fish would actually affect our auto depth, which would cause us to lift up quickly.
The fish are also at risk. Natural gas is toxic to marine life, so the crew doesn't want any leaks as they close this valve.
Yeah, we can confirm that that's now locked in position.
The torque tool is now attached to the top of the valve. The next step is to power it up.
It's in lock position, and now we're running the tool.
Okay, now we're running the tool.
The tool needs external power to operate, so a delicate handoff begins. The hydraulic power hose is moved from the torque tool to plug into the power supply of an ROV. With the torque tool powered up, the ROV pilots can remotely control how much the valve turns.
Clockwise and breakout torque of 56417 Newton meters to close, yeah?
Yeah, that's affirmative.
Almost 14 million liters of natural gas flow through this valve each minute, and it takes 3 cranks on the torque tool to close it.
So there you go, it's such a big valve, they've got to go back and forth a few times, like a ratchet idea to finally close the valve off.
The valve slowly closes, cutting off the natural gas supply to this part of the pipeline. With that done, it's safe to install the compressor.
Confirm that.
With the gas shut off, the ROVs return to the surface.
We've done a review of the weather forecasts, and looking forward, we've got around 2 metre HS at the moment, which is approximately 4.25 metre max waves. But this is obviously well within the conditions that we can accept for the SHS.
And now it's time for the biggest task of all, lowering the compressor into place.
5 meters to starboard. Yeah, it should be fine.
The weather is not perfectly calm, but it is well within our operational limits.
Yeah, we're ready to start lifting the module now.
It takes extraordinary strength to hoist this massive module. Each meter of steel wire weighs 45 kilograms, and the wire is double looped for the lift.
We are having more than 400 tons in the special crane right now. The compressor module itself weighs below 300, but we have the lifting frame and the cursor frame. You see the orange frame all the way up there.
In rough seas, the heaving of the ship on the surface could easily transfer to the load suspended from the crane, causing the compressor to bob up and down. But this crane has active heave compensation. That means the pulleys are engineered to counter the vertical movement of the waves and steady the load. The compressor's target position is 300 meters below the ship, with a margin of error of just a few centimeters. 4 years of planning and innovation have come down to this. North Sea Giant is lowering a 388-ton natural gas compressor to the sea floor, the biggest ever. It's being tracked by the cameras on 3 ROVs. The compressor descends slowly, so the air in the hollow struts can be replaced by seawater. If it arrives on the bottom with air in its supports, the pressure will cause it to implode. With no air left inside the compressor, the captain turns the Giant 90 degrees to port. This places the load over its final position on the sea floor, but it also exposes the starboard side of the ship to the wind. The entire mission depends on the ship staying still, so the compressor can be lowered exactly into place. For this, North Sea Giant relies on 5 Voith-Schneider tractor propellers. Unlike regular propellers, these act like egg beaters, hanging down vertically under the ship. Each 5,100 horsepower propeller has 6 blades that can change angles second to second to push the ship in any direction, compensating for wind and waves.
And they keep us within 10 centimeters of the exact spot where we want to be. We have up to 5 meters wave height, and wind speed is about 35 knots.
No one understands the challenge of tonight's mission better than Statoil project manager Morten Persson.
We're going to lower it down to 265 meters, entering the guideposts, so it's guided. It guides it safely in between the other neighbor modules. The clearance here is less than 1 meter. When it comes down, it will land softly on a controlled landing system.
With the ship in position, Andrew Shuttleworth takes over to direct the operation. The success or failure of this mission is on his shoulders now.
Okay, come down 8 meters. Yeah, you just lateral over to your left. That's fine, you stay there on post 1.
Andy will be responsible for lowering the compressor onto 2 guideposts. As the leader of this team, he gives orders to the crane, the ROVs, even the bridge.
Okay, just stand by on vessel move's got a few meters to run, just stand by. Okay, just come down 5 meters, speed 0.3.
This is the most critical phase. What's happening now is that we are lowering the compressor module onto these guide posts. They are quite tiny, as these are 12-inch in diameter and 16-meter high. This is really a critical operation. We can easily bend these guide posts. It is a matter of fine positioning the vessel. We're going sideways or forward aft in steps of 0.5 meters. And we're waiting for the correct time when we can lower it down.
To see what's happening, Andy relies on the ROV's 12 cameras.
Okay, if you come down 0.5 meter, speed 0.1.
Coming down 0.5 meter, speed 0.1.
The ROV images reveal a problem. One guidepost should be taller than the other, but they are actually both the same height.
This is almost impossible the way they're both level like this.
This means Andy will have to land the compressor on both guideposts simultaneously, threading 2 needles at once, 265 meters below the surface.
Okay, come down another 0.5 meter.
Coming down another half.
0.1. I'll stop.
Don't stop.
Andy needs the white guidepost to fit into the yellow funnel-shaped holes in the compressor. This is where the multi-million-dollar investment in the SHS crane is supposed to pay off.
We can see the wire down to the compressor module is going over those sheaves. When the vessel goes up, the winches pay in, and when the vessels go down, the winches pay out.
This dynamic system is called active heave compensation.
The movement of the vessel is plus minus 1 meter up and down, while the module only moves plus minus 10 centimeters.
Down below,
Bridge control.
the crane has lowered the compressor to just above the 2 posts.
Okay, I'll have 1 meter on 317.
1 meter on 317.
Yeah, speed 0.1.
This is the tricky part. Even a near miss is dangerous. If the guideposts are bent or broken by the compressor, this installation will have to be called off. But each time they line up the funnels over the posts,
I'll stop.
the compressor drifts away. Its position needs to be accurate to within 20 centimeters on top of both guideposts at once.
Well, the weather at the moment's a bit of a problem. We've got to come round so the weather's beam onto us, so we're getting some movement with the vessel.
The wind is hitting the side of the ship at 65 kilometers per hour, and she's struggling to stay in position.
Okay, bridge control.
Go ahead.
Okay, I'll just try half a meter 047.
Half a meter 047.
Yeah.
Andy asks the bridge to slightly alter the ship's position so the compressor will line up above the posts. Up on the bridge, the captain and his mate are manually adjusting the ship's position, battling the wind to keep the compressor on top of its destination on the sea floor. The ship's special propeller system is designed to compensate for heavy winds, but these are the strongest North Sea giant has ever faced when lowering a module.
Andy is under pressure now. We can break the guideposts, and then we have to abort the operation.
Stop.
This is the most critical moment. We have done it before, but today is the worst weather conditions. We have the wind and the waves almost directly in from the side of the ship.
Come on, 0.1.
0.1.
It's too narrow, isn't it? Okay, see, I'll shoot across now to supporter 1.
Go over to supporter 1.
Let me see that guidepost, Dev 1.
Andy has finally been able to position the compressor above the first post, but getting one post right isn't enough.
I'll come up anymore, I'll lose that one.
Once again, a strong wind pushes the ship and the compressor out of position. So Andy calls in some help.
Well, we get the ROVs to grab on to the corners so we can get there, get them to start helping us to orientate, just to get me in the area I want to be. Just give it a bit of a nudge there, please.
So far, the ROVs have just been watching the action.
Keep coming down. Come down 1 meter.
Now they use their claws to nudge the compressor into position. Andy hopes that the ROVs will be able to steady the compressor so he can lower it onto both guideposts at the same time.
Okay, once you get yourself in position, tell us you're good. I'm going to continue down.
Yeah, good.
Okay, let's say chest control.
Go ahead.
Okay, continue coming down at 0.1.
So you're coming down at 0.1.
With the ROV's help, the compressor finally lands on both of the guideposts.
Yeah.
Support 1, your tether.
Good job, Andy.
It can now slide all the way down to the subsea compression station.
Stand by there.
After working through the night, the compressor is finally in place. As morning breaks, North Sea Giant enters the history books. landing the compressor with unparalleled precision. This achievement will mean nothing unless the ROVs can connect the compressor to the rest of the station. Off the coast of Norway, North Sea Giant has just made history. The world's largest subsea compressor has been delivered safely to the bottom of the Norwegian Sea.
Support one, your tether.
The compressor is the last module for a new subsea natural gas extraction system 300 meters below the surface. New pressure will be added to 11 natural gas wells, extending their life by 20 years. But there's one step left. The compressor must be plugged in to become operational. Mitchell Pike is the lead engineer for Statoil, the company that owns the compressor and operates the gas field.
The compressor obviously needs power to run.
On the move, thank you.
Once this connection is made, we'll be able to start up our compressor and start compressing the gas.
Okay, just continue.
The compressor needs 12,000 volts to operate, so its power plug is huge. It weighs as much as 5 cars.
It's the largest subsea power connector in the world with the highest capacity. It's a massive step in technology, but this is what's required to power our large compressor module.
The connector is so big, it must be lowered like a drawbridge from the module next to the compressor.
All stop on play.
The bridge is in place.
That's good, we are happy with that.
But before the plug can be slid into the socket on the compressor, the ROVs have to clean grime off the exposed connectors.
The risk for us during this part of the operation is we have exactly 24 hours to complete the connection. So it means that we have to be very sure that things are going to go well before we start.
The ROVs will use a high-pressure water jet to clean the prongs and socket before the salt water creates corrosion. But in the control room, the ROV operators discover a malfunction. The water jet isn't working. So the ROV is sent back to the ship for repairs. Rolf Utne is in charge of finding out what's wrong.
We didn't have any flow and pressure on the water jetting system.
Rolf checks the pipes and pumps for broken parts and blockages.
So right now we are trying to pump fresh water through the system.
Something is keeping the water stuck inside the ROV.
I think it's the valve. We don't get any pressure out of the valve, so
That's the valve.
it may not be the pressure washer.
But the compressor's exposed plug and socket will be damaged by the salt in the seawater within 24 hours. So this has to get fixed now. If one of the parts needs to be replaced, it could take days to arrive.
We are at this stage under quite a pressure.
So far, Rolf has ruled out faulty pumps and clogged lines.
3A, ready when you are.
Now he is testing the valves.
So we just tried to swap output valves on the ROV, and it works.
It's a huge relief. This ROV is ready for action. The ROV returns down to the sea floor. The water jet sprays the exposed connectors on the compressor and the high voltage power coupling. With the cleaning finished, this giant plug can finally be pushed into the compressor.
We've had a successful connection for our high voltage bridge. So this is a fantastic milestone for the Oscar Subsea Compression project. Obviously, for the compressor to work, it needs electricity. So this is a very, very important milestone for us today.
The compressor is connected and powered up. After 8 months of work by the giant, the world's largest subsea compression station is complete.
This is in fact a very large success for the North Sea Giant. It proves again that it is the most capable ship in the North Sea.
Well, to be here 265 meters over the compressor station gives me enormous good feeling. We have been working 3 years for this project. There are 29 structures down there, 22 of them has been installed from this vessel.
To complete this historic mission, North Sea Giant has relied on every one of her advanced technologies. The moon pool, 3 ROVs, Voith-Schneider tractor propellers, and most of all, her special handling system crane.
I must admit, I'm very proud to be part of it. I was in Finland the day we cut the first steel for the SHS, and then to see it sitting here today, our special crane, working as it's intended, it's a very proud moment for me and everyone else in Statoil and our contractors.
For Morten, the Asgard project is a sort of fairy tale, the kind of job he'll tell his grandchildren about.
The North Sea Giant is the vessel we've been looking for this job. This boat can do anything.
But in this story, nothing slays the giant.